And now the recording is started. We get also all the repositories and all the example projects we do at this training after the training. The question is the most important stuff. Ask as many questions as you can. It's important. It's your training. We have enough time to answer all the questions you have. I think that's important. And these are the links to the different repositories and also to the MicroStream documentation, to the MicroStream GitHub repository. And I will also copy and paste the links of the example projects all the time to the chat. So that then you will be able to code along with me. Yeah, so we can do that. Let's have a look to the topics for today. As I said, Marcus will do a small MicroStream introduction around 45 minutes. Then we have a short look to a performance demonstration, just to show the differences between MicroStream and a PostgreSQL database. Maybe some of you have already seen that example, but it's all the time nice to see the differences, and there are some interesting points in it. Then I start with a small MicroStream quick demonstration. Then we talk a little bit about the proper data model and what's the important part of the data model. And then we go to a small Micronaut introduction, just a small one to enables you to create a Micronaut application to code along with me, because most of the examples we did in that training are based on Micronaut. Then we do a step-by-step configuration of MicroStream, a small CRUD project, and at the end, an exercise for today. And with that exercise, we start on the second day for tomorrow, just do all the improvements. Then we talk a lot of Java 8 streams and the Streams API and why to use it with MicroStream. Then we have the lazy loading part, also a very important part of MicroStream. We talk about legacy type mapping, some backup strategies. And at the end, if we have enough time, we will also have a look to an AWS S3 example and also a MariaDB example. But let's see if we have enough time. It's up to you. If you have a lot of questions, then we will use that time to answer the questions. Okay, that's all from my side for now. So I will hand over to Marcus, and Marcus, you can do your part. Stage is yours.
Thank you, Christian, for your introduction. And hello, everybody, for joining our fundamental training today. So great that you're here. And so this training, you will learn how you get started with MicroStream and really take the chance and ask the question, because Christian is one of our developers who writes the code, is involved in MicroStream development, and has experience, very experienced developer, and with many customer projects. So he can answer all of your technical questions. And if there are further technical questions we are able not, or should be not able to answer, then perhaps Florian could also join a Q&A session tomorrow. So, as Christian said, short introduction, but unfortunately, I only have introduction of myself. So, Christian, you can do your own introduction after my presentation. My name is Marcus Kett, and I'm CEO and co-founder of MicroStream. And around 20 years we're working with Java and working on development, Java developer tools and database developer tools. We run 3 open source projects. So MicroStream is one of these open source projects. Then we started with the RapidClips open source project. It's a visual Java development environment. It's also under, it's based on Eclipse. It's also under, I guess, EPL license. And so we also work on JPA SQL, which is also an open source project. We started with 10 years ago. We started with MicroStream, and now we're focused on MicroStream and built the company around the open source project. MicroStream itself is a Java native persistence layer that runs within your JVM process. It runs within your application, so it runs embedded or within your microservice written in Java. And it enables you to store any object graph, any complexity, any size persistently into any data storage. And vice versa, it allows you to load the object graph, restore your object graph in memory, but you don't have to load the entire object graph, so you can load single subgraphs dynamically when it's needed. And restore it in memory. And the loaded object references are automatically stored into you or merged into your object graph, so you don't have to deal with object copies. And this is the functional principle of MicroStream. So it's not a traditional database system. It works fundamentally different. But the good news, MicroStream works more Java-like. So it's a Java library. It's a part of your application. It's a kind of like storage function, and you don't have to build your application around a database system anymore. So it's the API is available on Maven. You can download it by including your dependencies. The code is on GitHub. It's under EPL license, which means you can use it for commercial purpose as well. You can use it for closed source applications. After we have open source MicroStream, Oracle has included MicroStream into Helidon. Now we are also well integrated with Micronaut. So we are very happy about this. So because Micronaut has built a great, a really beautiful integration with MicroStream. The MicroStream project is not a prototype or just a proof of concept. We started MicroStream almost 10 years ago, and 2 years later, first companies used it in production. And in 2019, we decided to start a company and build a company around the project. And in 2021, we have open source MicroStream. And since we have open sourced it, we are working on a cluster solution and a cloud solution, and to enable building distributed applications or microservices with MicroStream. As I mentioned already, MicroStream as a company is the main contributor to the open source project, but you're all invited to contribute code or to analyze the code, do bug fixing, or give us feedback, feature requests. So this is very important for us. We provide also large task coverage for the open source project and create the builds. And it's also important to earn money, of course, when you run a company. So we provide you update warranty for older MicroStream versions. We provide you with enterprise support, consulting, and now we are working on the enterprise edition again to to offer more powerful MicroStream, even less memory consumption and higher speed. So the question is, why do we need a micro persistence for microservices, or why do we need a new persistence for Java at all? And in our perspective, with our experience in database programming, improving JBoss Hibernate tools for almost 10 years, our opinion is, and what we've seen in practice, is that traditional Java persistence by using traditional database systems is mostly complex. It's heavy weight. The applications through runtime are mostly too slow, and in the cloud, they are mostly too expensive. The reason for that is that the Java and database systems, traditional database systems, are fundamentally different. They are incompatible. It's because Java uses objects for everything. Everything is object-oriented. But when we store data in a database and we use a relational database, then we have to store data in tables. And storing Java objects, for instance, more complex objects, object graph, the circular references, storing object graphs in tables is not possible from the technical perspective, because the data structure are completely different. There are several mismatches, so we call it the impedance, object relational impedance mismatches. And there are several, for instance, the object model is much more granular, mostly, than the relational model. In Java, we can use subtypes, and this is not possible in the relational model, and so on. So navigation through a relational model is not possible. We need a query language. We need SQL for that. Navigation through an object model is very easy in Java. Just have to call some get methods. The data types are completely different. Relational databases introduce mostly more than 30 data types, and they are incompatible with the Java types. So we have many mismatches here. And to solve this problem in practice, we need something between the application and the database. And the same with NoSQL databases. So the modern NoSQL databases, they have many advantages, and they introduce now completely new data structure. For me personally, this is the biggest difference between a relational model and the NoSQL databases. They provide new data structure and data models. For instance, the column store or the document-based databases, they mostly based on JSON or XML. Then we have the graph databases, and we have also the object-oriented databases that were invented in the 1990s. And we also have time series databases and so on. But all of these data structure are not compatible with the original and native Java object model. So we have the same issues here as well. And to solve it with relational databases, we use object relational mapping between the application and the database. And with the NoSQL databases, we need a data conversion. And object relational mapping or data conversion are executed through every single read and write. And this leads to a latency. And to accelerate database queries with traditional databases, we are forced to use caches, or mostly caches are used. This is a common way to accelerate queries. So we add a local cache, and as you can see, the architecture gets more and more complex. This is the common way. That's okay. But what happens if we build distributed applications? So if you run multiple instances of a Java application with local caches, then we might be in trouble, because what happens if one of these nodes changes an object and stores this object in a database? Then this node and the database are in sync, but all of the other instances are not in sync with the database. So we have a problem here with consistency. To solve this problem, the common way is to put the cache between the application and the database. And in practice, we want to avoid a single source of failure, which means we have to run the cluster here as well. So we need multiple machines here as well. So the architecture gets more and more complex, gets bigger and bigger. Now we add a distributed cache, and distributed caches are now able to sync the nodes or keep the cache nodes and the application nodes in sync. So that's great, but the complexity increases more and more. We need additional machines, and the costs in the cloud increase, or in your own data center. And if the load goes higher and higher and higher, then perhaps you should now also run a database cluster, which means we need multiple machines to run our database system. So complexity increases more and more, and we need another machines to run our database cluster. Then we have 3 layers, 3 cluster layers. So, and to manage these systems is very, it's very effortful in development, and it's very expensive through runtime. But this is the common way to do this. With Java, we believe we can do this much more convenient, much better. And this is the reason why we worked on in-memory data processing with Java. Traditional database systems always try or have to access to a hard disk. They are disk-based. But memory is much faster. Here we can see some numbers, and mostly access to a cache or to the memory directly is up to 1000x faster, sometimes 10,000x faster than a traditional database query. So the question is, can we benefit from this performance? And we believe, yes, we can definitely benefit from this performance, because with Java, we have almost everything we need for ultra-fast in-memory data processing. Everything we do with Java in memory is fast because of the JIT compiler of the JVM. So it optimizes your code, and so you get out almost machine code that is almost that fast as C programs. That's great performance. But Java also provides the perfect data structure and data model. Today, the database vendors are still searching for the best data model. So now we have the multi-model databases. They try to cover all these data models out there. But with Java, you have it already from the beginning. So because we can use Java object graphs, and the object model in Java is so flexible, you can do whatever you like. You can store single lists, you can use collections, you can store documents, single objects, and you can combine all of these data types, these Java types, and store it. So this is super convenient. With MicroStream, you can store it now. And in addition to that, Java provides us a great query language. For instance, Java Streams API, it allows us to search on object graphs and filter, and this is executed in memory. It's optimized by the JIT compiler. You can use parallel streams, And so this will be super fast. And all these queries you execute in object graph are executed in microseconds. So mostly in microseconds. No matter how complex your object graph is, so you can have millions of nodes in your object graph, and you search through the object graph, and will take only microseconds. This is a great performance. So in our opinion is, yeah, database application, database queries are executed in milliseconds. Java streams are executed in microseconds. So why don't we use this performance, this incredible performance, for building ultra-fast in-memory database applications with Java? The only thing missing so far in Java was a possibility to store your object graph. And this is what MicroStream adds to the Java ecosystem. This is not an invention by MicroStream. So the concept and the functional principle is, yeah, it's actually known from the beginning. And many developers have tried to persist their object without object relational mapping, or doing something more simple. And MicroStream based on the system prevalence pattern. And the concept is very simple. You just keep your objects in memory. So we assume that we can run bigger RAM applications, but in practice it's not mandatory. Now with MicroStream, we can also run MicroStream on micro machines, so small machines, less than one CPU, let's say serverless functions like AWS Lambda. So we have very small machines, and this is also possible. But when we are able to save money in the cloud, and we have then we can invest more in memory. So if you have more memory, then benefit from the memory. So keep the objects in memory, process your data in memory, then this will be super fast. But you need persistence, then just create a snapshot of your system state. So by snapshotting the changes, we can persist the data. This sounds very simple, but on the other hand, sounds not suited for enterprise database applications, because there are so many open questions and so many challenges with snapshots. So can this be really a professional way to store our objects? And MicroStream has solved all of these problems and answers all of these open questions in terms of, is this really a suited idea for running database applications in practice? So let's have a look on how this works. So here we have our app or microservice, our objects in memory. And now with MicroStream, we have a completely different functional principle. Let's have a look on what we have done. So let's have a look first into the database system, because this is very important. Because for most developers, the database server is a black box. So we just send an SQL and something magic happens inside a database and we get a result sent back. But what happens in a database internally, pretty much the same as we do with MicroStream, but we do it on the Java side. So the database systems also need big memory in a database server. The more memory you have, the faster your database will be executed. You have the database, you have also business logic in your database, if you use it or not. So this depends on you, but the vendors, they tell you, use stored procedures, stored functions, and put the business logic into the database. So it's your decision. Then we have, of course, the database management system. that cares for concurrency, validation, and so on. And of course, we have the storage data, the data on disk, how the database management system stores data persistently on disk. And nobody cares for how the database system stores the data on disk internally. It depends on the system. So many databases, they store it in a binary format. Some databases use human readable formats like JSON or XML. So this depends on the database vendor. In practice, as we have seen already, we use a mapping or a conversion between our app and or a microservice and the database, and we add a local cache. So this is the traditional way of storing data. And what we have done with MicroStream, we replace the conversion layer with MicroStream. So now MicroStream is responsible for storing our object graph. Because of we keep the data in memory, we search the data in memory, we use the object graph in memory as our in-memory database. So the objects are already in memory. We don't need a cache anymore. So now we can skip a local cache. Let's have a look on the database side. As I mentioned, so we use the object graph in memory as our in-memory database. All queries are executed in memory in the same JVM process as our business logic is executed, which means we don't need a database management system on a remote server, so we can skip it. And we don't have to keep data in memory on a database server side. So we can skip it. And we only focus on writing business logic in Java. So we don't need stored procedures or stored functions. The only thing MicroStream needs is the storage data in a binary format. We use a binary format because with a binary format, this allows us to store and handle even complex object graphs without any limits in terms of the depth of your object graph. You can use circular references. All of these is possible by using a binary format. And this is how MicroStream architecture looks like. There is no more mapping, no more data conversion between your app and the storage. And as a storage, you can use almost everything that is possible to store or that allows storing binaries. So it's obviously to use plain files. On the other hand, also database systems are able to store binaries, right? So blob stores are built for storing binaries. And this is the reason why MicroStream provides you connectors to database systems, and you can use also AWS S3 to store your binary data. So this is really recommended. But you also can use a traditional database system like Oracle to store your binary data. And Oracle does pretty much the same because Oracle also provides different data structure to store. For instance, Oracle provides you a graph model, and they also have a layer on top of their relational database and store binaries in their relational database. So it's pretty much the same functional principle we provide with MicroStream. And you can choose your storage target. The requirements are really low, so there are no requirements. MicroStream runs wherever Java runs, on a desktop, on a server, in a cloud, in a container. It also works with GraalVM native images. And we have an implementation for Android. The only requirement is Java version 8. So MicroStream creates a snapshot of the changes of your object graph. So each store is a snapshot. So we serialize the data in a binary format, but we don't use the Java serialization for that. The Java built-in serialization, because there are security issues with the Java serialization, and there are also limits with the Java serialization. For instance, the depth of your object graph, the performance, and so on. This is the reason why MicroStream bases on a fundamentally new written serialization, and the MicroStream serialization is the core of MicroStream. On top of the serialization, we provide a persistence layer that provides you many additional functions. So this is not only creating a snapshot using serialization and then store the binaries. There are so many additional functions in this persistence layer. You will learn the upcoming 2 days. As I mentioned, we provide a similar implementation for Android. It works pretty much the same. It's pretty much the same API. So if any one of you is interested in building a back-end solution that is connected to mobile devices or edge devices, you can use MicroStream for both implementations and both platforms. There are many functions on top of the persistence layer, as I mentioned. For instance, legacy type mapping. So we answer all of these questions. Creating a snapshot is great, but what is if my Java classes change? Then I'm in trouble. No, you are not, because we have this legacy type mapping that solves all these changes automatically for you. We store we store a binary format. We store the binary information of any changes in a blob appended to your file storage. So each store is a new binary file in your storage, which means your storage will grow more and more. You change your objects, then you have legacy objects in your storage. Oh my God, the storage gets bigger and bigger. No worries, we have a so-called file system garbage collector that cares for removing your older or legacy object from your file storage and keep your file storage clean and small. We also have a file system abstraction that allows you to store your binary format, your binary data, so your persistent data almost everywhere. So you can store it in a mounted volume, for instance. You can store it in a database system. You can store it on a local system or a system that runs anywhere. So this is provided by the file system abstraction. And already mentioned the database connectors. We also provide you a REST interface that allows you to have access to your storage data, have a look on your storage data, and then we have a graphical user interface that allows you to browse through your storage data. We have native backup functions. If you use a database system, you can of course use the database system's backup functions, but if you use plain files, then MicroStream provides you backup strategies. We have also converter to put your data into MicroStream application, or to get data out from a MicroStream application. For instance, CSV is provided. We also work on other encodings, for instance, protocol buffer and JSON. They are work in progress. And finally, we now add MicroStream cluster that allows you to run multiple instances of your app or your microservice to build distributed systems. And this package is MicroStream. So distributed applications with MicroStream. So one of the most asked questions is, can I run multiple instances of my app or service can I build distributed applications with MicroStream. And so far, this was not possible to build distributed systems with MicroStream, because MicroStream was built as a single store, as a single JVM, as a single node storage. Because we designed MicroStream almost 10 years ago. 10 years ago, most of you guys, so I'm convinced, have developed monolithic applications, and monolithic applications mostly run on one big machine, a big application server that runs on one big machine. So nobody was talking about microservices. So the design concept was built for monolithic applications, but now the world has changed, and now we need microservices and run small distributed systems. With MicroStream now we are able to replace your traditional Java persistence, which means now in a cluster environment you can now replace your classic application nodes with MicroStream application nodes. They will be much more powerful because of the performance. Each query is executed sometimes 10, sometimes 100x faster, but often more than 1000x faster, which means you won't need the same amount of CPU power or machine power. So with only one MicroStream machine, you can replace 10 or even up to 20 traditional nodes of your application cluster. This is really powerful, and so we save lots of CPU power and resources in the data center. Okay, with MicroStream, as I mentioned, so I repeat it all the time because it's super important. Your data in memory is your in-memory database. They are in memory already. We don't need a local cache anymore. And now with the MicroStream cluster, we are able to replicate the object graph through hundreds or thousands of JVM processes, so hundreds or thousands of nodes, which means we don't need a database cluster anymore. So we can skip the database cluster from our architecture landscape. We only need a data storage that is able to store binaries. If you use S3, then, for instance, your storage data are also automatically clustered. We replicate the object graph in memory, which means we don't need a local cache anymore. We don't need a distributed cache anymore. So we can also skip the distributed cache cluster from the architectural landscape. And now the architecture becomes super simple. The architecture of a local machine becomes super simple, and also the architecture of a distributed system becomes very, very simple, and we save tons of CPU power. And now, this is very important part. At this point, I like to recommend you can invest now in bigger RAM machines. So now use the money, invest in more memory, and then this is more powerful with MicroStream. With MicroStream, as I mentioned, you can run also small machines, only one CPU, 1 GB memory. This will work, but if you have much more memory, of course, MicroStream will be much more powerful, because we talk about in-memory computing and in-memory data processing, which means this happens in memory. You need memory. So, and even if you run a distributed cache, your cache machines, your cache nodes will need memory, or use an in-memory data grid or in-memory database. You need memory. With MicroStream, you also can benefit from memory. It's not mandatory, but it's recommended, and it's, of course, an advantage. And with these cost savings, you can be happy of your cost savings, or you say, okay, then I'm now able to invest in bigger memory machines. All right, this is the functional principle. There are also challenges with MicroStream. So we also want to talk about the challenges, because there are challenges. This is the reason why we provide training. And actually, the biggest challenge with MicroStream is the mindset of the developer, because now you have to think a little bit different. There are no more remote database servers you call. So there is no more remote database server. You send a query and the query is executed at the remote database server. With MicroStream, this is fundamentally different. Your data are located directly at your application, and the queries are executed in the same process as your application or a microservice. This is fundamentally different, and this is a paradigm shift in database programming. The biggest challenge is for developers not to think relational anymore. Please don't think as a database developer anymore. Forget everything you have heard about database server concepts. Think as a Java developer. You don't have to learn new concepts with MicroStream. So we don't force you to use now our own proprietary magic concepts. Just think as the Java developer, just think object-oriented, and that's it. We use Java core features only. There is no magic. We use just the JVM power, just object-oriented concept, object model, and that's it. But there are further challenges. So we have no database system anymore. We are not the database system that cares for everything, and so you have to care for concurrency. Java provides everything we need for that, but keep in mind, you have to care for concurrency. MicroStream provides you deep copies and something specifics in our API to support you, but use the core Java concepts. You have to care for validation. In practice, database systems care for validation, but in practice, mostly Java developers care for that anyway. And we care for concurrency finally anyway, to avoid deadlocks in the database, and we don't use pessimistic locks and so on. So this is not really changing. So we do it anyway. This is our opinion. And it's not suited for DBAs, so there is no possibility to execute a query somewhere else. So this is plain Java. Okay. If Christian can give me some more 8 minutes, then perhaps we can have a look on how MicroStream works. The fundamental principle on the object graph. As I mentioned, you can build your object model freely, and this is also challenging for Java developers sometimes because there are no rules. Hey, with all these technologies out there, there are rules. With MicroStream, there are no rules. How can this happen? So with MicroStream, you can build your own individual object model freely, and there are no requirements. You can store almost everything you build with Java. So you can use any Java type, you can use collections, you can use circular references in your object graph, you can use simple lists. Yeah, do whatever you like, you'll be able to store it. You don't have to, there are no requirements to your classes. You don't have to implement serializable. So which means you also can use and store objects of third-party libraries. No requirements to your classes, no annotations, no superclass. Just use plain Java objects, just POJOs, and you'll be able to store it. The only thing really you need to get started is a MicroStream instance. Christian will show you the code. I will show you some graphics, how this works on your object graph. So in memory, you need a MicroStream instance and a root object. This is very simple. And all objects that are reachable from this root object, this is your database, and this can be stored persistently by MicroStream. So together with your root object, MicroStream creates a storage anywhere. Let's say plain file, binary storage, anywhere on your system, perhaps on mounted volumes that you mount to your container. Then let's add and store some objects here. You can store objects by calling only one store method. And oh, there is a rule again. Second rule, you have to store the object that is changed, which means store the owner objects, which means if you have changed an object in your collection, you have to store the owner. You have to store the collection. This is the only rule. And it's only a store method. That's it. The store method is an atomic operation, all or nothing operation. It's transaction safe. So you don't have to care about anything else. Okay, let's add an object here and let's store it. And then you have a new binary file in your file storage, because now we have stored this object in a binary format in the file storage. Okay, let's add some more objects to our root object, and let's store it. Then we have another binary file in our file storage, and so on. So now we can add more and more objects, object instances, and store it, and we will create binary files again and again. So every single store is a new binary file in your file storage. So what happens if we change objects on our object graph? Be careful when you change objects on your object graph, because you have to care for concurrency. MicroStream provides deep copies for that, but you don't have to use it. So we can use whatever Java provides, but let's change an object. And this is very interesting. Now we store the object reference. What happens in the file storage? A new blob is added. So we never override existing data in a file storage like the relational databases do. This will never happen with MicroStream. All changes cause to new blobs in your file storage. So is this dramatically? Because now our storage will grow more and more. No, we have our garbage collector, and under the hood, MicroStream provides a specific thread that cares for housekeeping and reorganizes your storage all the time behind the scenes. So you don't have to care for that. All right, let's see what happens if we start an application. This is very interesting. So we create this MicroStream instance. We have our data storage already on disk. And as soon as the application starts, MicroStream loads all objects IDs into the memory, which means all information about your object graph, your used objects are now loaded into the memory. But no data are loaded. Only the object IDs are loaded. So we get MicroStream gets information about the entire object graph in memory, but you as a developer can now decide, do you want to load data initially into the memory, or if you want to load data on demand only by using lazy loading. if you do nothing, then MicroStream uses eager loading and loads the data automatically. If you define your classes lazy, MicroStream will only load the object IDs. Okay, and there are no more classic selects. So now we need some more data in our memory, in our system. Just call get methods. There are no classic selects. There is no database system you could send a select. Just call get method. So this concept is fully object oriented. Go through your object graph and call get methods. And MicroStream will load the object references and merge it directly into your object graph. That's it. Fully automatic. It's fully object oriented. And very convenient to use. I mentioned lazy loading. How does this look like if you have, if you don't use lazy loading, then you don't have to make any changes to your classes. Then everything is eager, and MicroStream loads the objects initially into the memory. If you use this lazy type, then your the object, the data are the object references are only loaded when you call the get method. So then we load more and more data into the memory by using lazy loading, and so which means the memory consumption gets higher and higher. So do we run out of memory? No, we don't, because you have fully control of your lazy references. You can clear your lazy references anytime. You can define timeouts to clear your lazy references, and then MicroStream kicks the lazy reference out of the memory, keeps the object ID, and if you call a get method, MicroStream loads the lazy reference again and merges into your object graph again. So this is the functional principle, how it works. And if you run out of memory, MicroStream automatically removes the lazy references from your memory more aggressively, so you never run out of memory. That's it, actually. And if you want now to search on object graph on your data, you can use JavaStream's API. This is a part of the training course. If you change classes, then we provide the legacy type mapping. And by the way, if you remove object from your object graph, it's also, and you have to store it, then you also store a new binary to the file storage. In memory, the garbage collector is responsible for removing objects that are not more reachable from the root object, and MicroStream cares for the data storage side. MicroStream garbage collection. This was what I wanted to mention before, actually. So if I change a class, then suddenly we have a problem here. It's because when MicroStream loads the object, it compares your object with the class. And if there are changes, then these changes can be solved by MicroStream automatically behind the scenes because of a heuristic that is implemented. And simple cases can be solved by this heuristic. Simple cases, if you add a field, if you remove a field, if you rename a field, if you change primitive types, this can be solved by the heuristic of MicroStream automatically. In more complex cases, if you change objects, for instance, then you can define a legacy type mapping, and then you store your object again, and then you have two versions of your object in the file storage. Here we can see that the red the red blob is a version of our previous object, and the yellow one is now the latest version of our object. So we have now legacy objects in our file storage, and you can define as a developer how MicroStream should handle these legacy objects in the file storage. You can keep it, but you also can tell the garbage collector, the MicroStream garbage collector, that works in its own thread, to remove all these legacy objects from the file storage behind the scenes, and then MicroStream clears and keeps your storage small and reorganizes your file storage all the time behind the scenes. All right. Conclusion. Please think different, because it's a fundamental change in database programming. On the left side, you can see the traditional database server paradigm. There is a database server. All queries are executed on the database server. The storage data are stored on the database server side, and the application runs on the application node. With MicroStream, this is now completely different, because your object graph in memory becomes your in-memory database. Searching queries are executed directly in your application node with Java streams. This is the reason why this is so fast. You just have to call get methods to load object references in your memory. MicroStream cares for the memory management, and only the storage, the binary data, the representation of your objects are stored persistently anywhere, into a file storage anywhere. And secondly, big question, do I need big memory machines? If you can run big memory machines because you have saved tons of infrastructure costs with MicroStream, please invest in bigger memory machines. But if this is not possible, it's not a problem. So if you have a small database size and you have big memory size, you can load the entire database into the memory and execute everything in memory. This is possible and recommended, but it depends on your use case. As I mentioned, this is not suited for microservices, because with microservices, you want to have a fast startup time. You don't want to load the entire database into the memory. So this will slow down your startup time. If you build a monolithic application, a monolithic system, you start it once and you run it for 2 years, no shutdowns, then this is a great approach and the way to do it. On the right side, we can see here we have smaller machines, only 4 GB memory, but we have a huge storage size. Then, of course, you cannot load the entire database into memory. This is not possible, and this is also not recommended. Use lazy loading for this use case, and then you're good to go. These are the rules, and please think object-oriented. And now I will hand over to Christian, and he will show the code, explain the functional principles in more detail by showing and introducing the code. Thank you for joining. If you have any questions, we can now do a little Q&A. So take the chance. It's on you. Otherwise, I hand over to Christian. Thank you.
Yeah, thank you, Marcus. So we had a few questions during the presentation. I think most of them I could answer. We had one for if you have a Neo4j connector. I answered this. There is no Neo4j connector in place at the moment. And yeah, we are not sure if the binary structure of MicroStream fits best or fits good to Neo4j. That's the reason why we don't have a connector. But yeah, as I said, it's totally up to you. If you and yeah, you have to consider that we are not expert in all of the technologies on the market. So that means if you have any suggestions for a storage connector or something like that, it's basically open source, or give us a mail, send us a mail, or contact us via our support portal, and yeah, we will evaluate that.
Christian, I'm sorry for interrupting. This is very important to mention at this point. Please keep in mind, we never transfer the Java object model to a database model, which means we will never do a mapping. We only store MicroStream in a MicroStream binary format. So we would never transform the Java object model to a Neo4j graph model. It's because we would do the same, it's hard to say mistakes, but if we do a mapping, so then we would run in all these challenges again we have with this object relational impedance mismatches. This is the core reason why we have these challenges in database programming. So complicated architecture, complicated code, you have to care for two models. You have to care for your classes and the database model. And they are not compatible. So there are limits. You have to build your application around your database. These are the reasons why we never will do a conversion or a transformation of the Java object model to a database specific model. This is very important. So we use the object graph in memory, we use the native Java object model and store it without any changes, without any conversion, without latency through runtime. This is the benefit of MicroStream. And perhaps the question was really only storing binaries in Neo4j. So if Neo4j is also, and I guess it allows you to store binaries, then you can write a connector for any database that is able to store blobs. You can use it basically.
Yeah, this was the question. Thank you, Marcus.
Yeah.
Okay, so there are another question, but I think they are already answered, and that's okay. And especially there are some topics for tomorrow. We will talk about that in detail tomorrow. So I think that would be the best to wait for tomorrow. Okay, give me just the chance to introduce myself a little bit before we get into the performance demonstration. So yeah, my name is Christian. I've joined MicroStream on 2019. Started to work with on some Q&A stuff and so on. And after that, I did a lot of specification around of all the convenient stuff around the core framework. And after that, I did, or at the moment, I'm working on two of our biggest project we have together with MicroStream. And we are working on the German airport Fraport, on the baggage concealing system. This is a great project also with MicroStream. And there is a second one with the Allianz Insurance Company. We use MicroStream instead of using MongoDB in that case. Yeah, and that's why yeah, I worked a lot with MicroStream, and I knew a lot of all that best practice stuff, all the do's and don'ts of MicroStream. So I think that's the reason why I'm the best for that training. So if you have any questions, feel free to answer. And I have to correct Marcus a little bit. At one slide, there was the point that you can add third-party objects to MicroStream. And basically, Marcus is right in that point, but I would not recommend this to do that, because if there are any changes because of version upgrades, you will get in trouble, maybe. And I would not recommend to add third-party libraries to MicroStream, but you are able to do that. Basically, that's possible. Okay.
Christian, this is perhaps more a use case for our plain serializer.
Basically, yeah, maybe. Yeah.
Thank you.
Okay, so let's get into the performance demonstration. I will give you a short introduction about the architecture of that demonstration. So this is the architecture itself. So we have one sender application here on the bottom, and we have two different EC2 instances. One is an EC2 instance with a Micronaut application, which includes MicroStream. And this MicroStream instance stores the data to normal files on the EC2 instance and provide the data via REST endpoint. And we have barely the same on the right side. We have an EC2 instance, but with a PostgreSQL server on it. It's part of the same EC2 instance. And then we have also a Micronaut application with Hibernate, and it also provides REST endpoints in that case. And what we do is we send a lot of requests to both instances, and we measure the time in between with Prometheus and Grafana. We make the data visible on a Grafana board. And yeah, let's have a look to that. Give me just a second to start. So let me show. Okay, this is the sender application. So we have 4 different tasks here. The first one is a book call for 1,500 books with a title, value, author, and ISBN. Really straightforward.
Christian, you don't have shared your screen.
Oh, thank you. Okay, now you can hear me? Okay, something went wrong. Okay, so here's the architecture again. So as I said, we have 2 EC2 instances, one on the left, one on the right, one with PostgreSQL, one with MicroStream. Both of the databases stores the file on the EC2 instance, and in the middle we have the Prometheus, and we have the sender application, as I said. Okay. This is the sender application with the 4 different tasks. The first one, as I said, it's really straightforward, just a simple call for 1,500 books with title, value, author, and ISBN, only 4 or 5 fields in that case. Let's see what happened there. Then we have a lazy call. It's the same call like the first one, but the difference is that both instances, MicroStream and also Postgre, don't use any caches in that case. So we don't have a Hibernate cache on the PostgreSQL side, and we also we only use lazy references on the MicroStream side. Then we have a third call, the average call. It's just a small one to count the average costs of that books. And at the end, we have a join call, where we join many more information like the addresses and shop names and so on, and see what is the result. So, and let's start with the first example. Let's start to send requests, and give me the chance to share the Grafana board in that case. It always needs a little bit to calculate the average of the calls. So what we can see here is we have on that side we have the calls per minute, and on the right side we have the time we need, the time in milliseconds, the answer needs. So for the request or for the response, I would say. And here at the bottom, we have the CPU and the CPU load and on both sides, CPU on MicroStream, CPU on the PostgreSQL machine. And you can see the differences we have 500 around, or 550 versus 1200, and this is, by the way, the maximum of the sender application can send. So probably we would be definitely much more if the sender application could do more, but that's totally enough, I guess. The interesting part is both machines are working in memory, because Hibernate uses its in-memory cache or its cache, and MicroStream uses, of course, in-memory stuff. But you can see here the differences on the CPU side. And the important question is, why are that amount of differences between the CPU? We have an idea why that is the case, or what's the reason for these high amount of CPU usage on the left side? So let me open the chat. Maybe that makes it easier. Anyone? An idea? Both machines are working in memory. And I think, or the point is that you have to do a data mapping on the Hibernate side. So because the Hibernate cache is not structured in objects. So, and that's the reason why we have to convert the data from the cache to the objects, and that's the reason why we have that a huge amount of CPU usage on the PostgreSQL side. So it's not a problem of the Postgre database itself, but it's a problem on the data mapping side, and that's the reason why we have such huge amount of CPU usage in that case. Okay, let's have a look to the next example. Here we are. Let's stop that task. Let's use the in-memory, the lazy task. As I said, the data stays on the hard disk and has to be loaded all the time. I have to change the tab here. Okay, the applications are up and running. Let's wait for the refresh. Now. So now, as you can see, okay, we need CPU on both sides, because both sides have to load or has to load the data all the time. I think that's quite normal. But the interesting point is, you can see that here the differences on the response time. We have 339 milliseconds on the PostgreSQL side, and we have 67 milliseconds on the MicroStream side. And this is also yeah, you can see that in the calls per minute, huge differences between both technologies. And also that there are the same reasons, data mapping and so on. You have to load the data. It's all the time the same, I would say. Okay, let's switch to the next point. So stop it. The interesting point is the average. It's a really, really small request. And this is also quite interesting. It's called the aggregate call. I started it. I think we won't have big CPU usage on both machines because of that call is such a small call. It doesn't need that many CPU in that case. But again, in that both machines will have around 1,200 responses per minute. Both machines will reach the limit of the sender. But the interesting part is, again, the amount of response time we have. We have milliseconds versus microseconds, and that is quite impressive. So if we are able, or if we were able to call much more or to send more requests, we would also see the differences here in the calls per minute. But yeah, you can, as you can see here, milliseconds versus microseconds in that case, and that is yeah, quite different. Okay, and last but not least, let's have a look to the last call, the join call. And as I said, yeah, the join call is quite heavyweight for both machines. So I'm pretty sure both machines will run to the maximum of CPU. But let's see the result. I'll cancel this, aggregate. That is the join call. Yeah, as I said, we have a huge CPU usage on both machines. And you see the differences also on the response time, seconds versus milliseconds, and you see the amount of requests per minute or calls per minute or operations per minute. And this is quite impressive, I would say. So, and the result of that performance test is it's very important, because it shows you that with MicroStream you will be able to save tons of infrastructure costs, and also you are able to run machines with less CPU and less RAM, for example, and you will get the same result in the end. So if there are any questions, feel free to answer to that demonstration. So it takes always a little bit to calculate the average, but I think now we are okay on that join call, and you can see here we have the same CPU, but the result is really different. That's quite interesting. Any questions so far to that demonstration? Some people would say, okay, that's not a fair comparison, because PostgreSQL, it's a totally different storage, I would say. And yeah, basically you are right. But in the end, when you use Hibernate, for example, you have a cache also. And it's important to know that when you have a cache, you need a mapping anyway. So, and that's I think that's important to know, that the mapping part is the heavyweight part of the for a relational database, and that's important to know. Okay, stop the demonstration, and with based on that demonstration, we will have a short break. After that, we start with the first our first project, a small one. Okay, so let's jump into the first example I want to share with you. And in that case, I created a very basic Maven project. So if you want to code along with me, then just create a Maven basic project in your IDE, or it's totally up to you. The basic stuff we need, this is the POM XML. In my case, there is only one dependency, and it is the MicroStream storage embedded dependency with the version 7.01. You can find this version, or you can find those information also in our documentation. So let me just share the URL to the documentation within the chat. So this is the URL to the getting started, and the getting started is this example I want to share with you now is an extended version, I would say, of the getting started in the documentation. But here you can find the dependency. And as I said, just create a Maven basic project. And of course, we need one main class to write down our code. And it should be Java 1.8 or Java 8, I would say, at least. Okay, if you are ready, just give me a small sign, raise your hand or something like that, or show a thumb up, something like that. Then I know I can go on. Okay, great. I have one thumb here. As I said, a normal Maven project with a main method in it, and you will need the dependency on the POM XML. So, okay, so the very first object we need is the storage manager. And I would say it's the most important object within MicroStream. And we have to initialize this storage manager. And for that, let's do it like this. So let's say embedded storage manager. And let's give him the name storage manager. And to initialize that, we use the embedded storage.start. So, and as you can see here, we need some further information. Of course, we can do the startup without any parameters, but in that case, I'd like to use some parameters. The first one is the root object. So it's this one, or this, I would say. So that means we need one root object. And the reason for that root, we are talking about that later. And we also need the information where the data should be stored on the hard disk in that case. And we don't have that information at the moment, especially for the root object. Then we say, let's say null for the moment. But for the path, we can use path.get and let's say data. So with that configuration, data will be stored directly inside the application itself. So you can see that here on the left side, there is one folder which is called data. You would not need to create that data. It will be created automatically. So that is the easiest way to instantiate a storage manager with only two information. One is the root object. I would say the main entrance to the storage itself, or to the object graph itself. And the second one is the location where the data are on your hard disk in that case. Okay, let's create that root object. And this root object could be only a technical object, or it could be an object based on your business logic. So, and in my case, I want to use a business object. So let's create a normal class within my domain package here. So for your information, so I created the main class within the main package, and I created a domain package. And within that domain package, I will create a class, and I call that class my company. So let's imagine we want to store customers and orders and something like that. But the main entrance is my company itself. That is the class which contains all the collections we need for the data structure. So that means that is my root object, and we need one instance of this root object. And let's create this instance here. So let's say new my company. And now I can hand over my company to the embedded storage. And also for the future, these two parameters are the most important ones for MicroStream. It needs to know what is the root object, or what is the main entrance to the data structure, and what is the storage path. In a case when you want to store the data on your hard disk. So we use that also a lot, because especially when we use MicroStream on any Docker container, Kubernetes, or something like that, we most of the time we use the persistent volumes, and then we store the data directly to that volume mounts. And for that, we use this a lot in the past. Okay, we have the root object, and then we need another object, or another entity, I would say, to store this inside my company. And as I said, let's create one customer, or let's create a customer object. Just create a few fields. Let's say, okay, we have private name, for example. Of course, it's a string, I would say. Then we have a second one, private string. Let's call it, first name, for example. And maybe in some cases we need an kind of like an identifier. And because of that, let's say the identifier of a customer is the email address. So that's the identifier, and that is also one of the one of the most asked questions, I would say. Do we need those primary keys with MicroStream, and how to use the relations between the objects and so on? And I would say you need an identifier. That's all you need. You have to find a way to identify your objects. But you don't have those primary keys or those foreign keys anymore. You don't need it anymore. Just find a valid identifier of your object, and that's all you have to all you need. So let's create some get and set methods. And we also need a constructor. Let's choose this one, where we can hand over mail, name, and first name to the customer to create a custom object. And now we have to find a solution or a collection within my root object to store those customers. And for that, I choose a very basic collection. Let's take a list, typed customer, and let's call this customers. And I would say this is the main difference to the Hibernate and relational database approach. In that case, we have to take care about the collection of customer itself instead of having a table. And let's say we have our company, and within that company, we have a lot of customers which are stored. Let's say we need also a get and set method for those customers. And that's it. We could also say, let's say, private final. I think that would be best. And then, so that means we don't want to change the, we don't want to change the list itself. We just add some customers to the list. Okay, again, so we create our root, we created our root object, and we created one entity, which is called customer, which contains few attributes, male, name, and first name. We created a constructor, and we also created some get and set methods. And of course, some of you would create some an equals method, for example, and then toString override method and something like that. That's up to you. The important thing is you won't need any annotations, but if you want, you can use it, of course. So if you want to use Lombok, for example, it's totally up to you. You can do that, but I don't need this in my example now. Okay, so let's switch back to the main method. Okay, we have the my company instance here. We have initialized the storage manager, and now we can start to add some new customers. And for that reason, let's say new customer. So customer, let's say, okay, we need the name. Let's say it's Joe. John, of course. Let's say, yeah, doesn't matter. John dot Doe at example, whatever. Yeah, doesn't matter. And let's create another one. Let's say, let's use my name for that. Stream .1. So let's assign this to a local variable. That makes sense to have that. Two customers. Now we have to store these two customers. But first we have to put these two customers to our customer collection within the root object. And for that reason, we say my company. Oh, we need the instance itself. So let's say my company dot give me the customers. And then I say, no, let's do it. Let's do it in add customer 1 and add customer 2. And I think that's, yeah, until this is really, really straightforward, nothing special, only Java code. But the question is how to store these customers now. And Marcus already mentioned that with MicroStream, we only store the object which has changed. And in our case, these objects are new, and these objects are added to the company collection, which is returned by get customers. And we change the collection itself. And that means we have to store this collection because we changed the amount of entries in the collection itself. And then we have to store the collection itself. That means let's use the storage manager in that case, .store. And let's say my company get customers. And that's it. This is all we have to do to store the data to the hard disk. So let's add some code to see the customers in the console. So let's iterate through the customers itself. Let's say my company dot get customers dot stream dot for each C for customer, and then say system out C dot get mail plus C dot get name. I think that's enough. Just iterate through the customers and show this string on the console. Okay, did I forget something? So we have the root object, we have the storage manager. We created some customers and added them to the root object. We stored the collection within the root, and then, yeah, just iterate through the objects. And let's start the application. Okay, we see the two objects, but that is nothing special because for the moment, we added it to that collection. So the objects are, really obvious in the collection. But the interesting part is when we now refresh the project itself, we see the data folder here. And this data folder is created also on the hard disk. Give me just the chance to show this in System Explorer. Let's have a look to the data itself. So here you can see the content of that folder. We have one channel folder, and the channel folder contains the data itself. I think that's the data folder, and there is also a transaction file which contains all the different store and transaction stuff the database needs to stay consistent. And also, if there are some errors during the store process, the transaction file helps to keep the storage itself consistent. And then we have the persistence type dictionary, and that is also an important file which contains the structure of the different objects of the MicroStream storage. And this is one of the, I would say, most important files because it's needed all the time to parse the binary files on the hard disk. And you should handle that persistent type dictionary very carefully. So it's a very important file you need. Okay, we have one question in the chat. Could I also just restore my company and it stores also the customer list? Basically there is a possibility to only store my company. That's possible. but not with the default lazy storing strategy. We talk about that a little bit later. There are different store methods you can use, but you have to consider that whenever you store, in that case, the customer list, as Marcus said, every store will be attached to the end of the storage. And for that reason, it makes sense to store the lowest or the smallest object all the time. And for that, that makes more sense to store the collection itself instead storing the whole company object, because this root object could contain much more objects in the end. And then it makes no sense to store the whole company, because this whole company will be attached to the storage again. And of course, the housekeeping process takes care about to shrink the database again. But yeah, it's not the recommended way to do. Just store the object which has changed. Okay, so let's find out if the data is really stored. So, and for that reason, just remove these lines of code. And when we now run the application again, we should see these two customers again. So let's do it like this. Let's say run Java application. Let's say yes. And here they are. These two customers are stored in our storage. Some more question to that example. And this is, yeah, as I said, this is the basic workflow of using MicroStream. And yeah, that repeats all the time. Just change some objects, store the objects. It's, yeah, all the time it's the same. It's really, really easy to use, I would say. Of course, there is no email because I missed to do that. But yeah, let's do that. I forgot to add the email information. Let's say c.get mail, and now you would be able to see the mail also. Okay, you are right. So I forgot to, where is it? Just, this is the customer mail first name. Let me check that.
It was basically a small confusion when setting up the customer. So the first string should be the email.
Okay, thank you. That helps. Okay, so let's do that again. This is just quite simple. So let me check. Let me double check that. Okay, I have mail name and first name. Okay, and then okay. So let's put this there. So let's remove the comma and let's do the same here. Okay, now the email comes first, and then John. First name, okay. Get. Wow, okay, and then I have to choose the name, and then let's say the first name in the end. Okay, so let's delete the data. It will be created again anyway. So let's start, run as Java application. Now it should be the right result. So let's disable this part of the code. Let's refresh it. The data folder is back again, and then let's start the application again. yeah, now it's working as expected. Is that okay for you? Yeah, live coding all the time. It's a great mess all the time. Some more questions from your side.
Just a small one. If you wouldn't have deleted the data folder and executed the path again, then most likely, as you said, the blob should have been recreated and later the garbage collector removes the old one, right?
Yeah, that's right. So that's also, we recommend that, especially during all the development process, when the data changed a lot or when the classes changed a lot, don't keep the storage all the time. Just delete the storage all the time and create a new one. Let's set up a good mock-up strategy. I think that's the recommendation on that part, and delete the storage again and again, and only change that strategy when you run into or when you're going to production. Then you have to change the strategy, then you have to deal with the legacy type mapping and so on. But this is a part for tomorrow. Yeah, just delete the data all the time and it will be recreated. It's better to create or to use a proper mockup strategy. Okay, so based on that, many people ask us, okay, so we're coming from Hibernate, or we're using some other technologies. What about the data structure? What is the best practice of data structure or creating a data model? And for that reason, I created a small presentation to that topic and how to create a proper data structure. And give me just a second to open that presentation. Okay, here we are. A proper data model. So some of you might say, okay, that's quite an annoying topic, but in some parts, it could also be quite helpful to know the differences between the relational model and also the graph model, some opportunities to design a graph. And I would say there are a lot of differences and a lot of opportunities using your object graph. There is also all the time the question how to handle bidirectionals and what are bidirectionals, especially. This is a big topic or a huge topic on the Hibernate side, I would say. And also the question all the time, how does the graph influence the UI? And this is also the case in many times. Let's have a look to the relational model. So we have a lot of tables and we have the connections between those tables with primary keys and foreign keys. I think every one of you knows that structure. And I also created a small example. I will show you that later on. And this is an object graph. And the interesting point of that is the left side, the relational model. This is how you store the data normally within relational databases. And you will get the right side, the object graph, when you use Hibernate in the end. And that is what we talked about, that data mapping stuff and so on. And yeah, mostly, but you are forced to create an object graph which fits best to the relational model. And that's also not the best way. And in some cases, the object graph within MicroStream will be totally different to the object graph you will get when you use Hibernate, for example. But when you start with MicroStream, you will be fine when you use this, or when you use the same object graph, which is really very similar to your graph from Hibernate. So yeah, this is the relational one. So it's more like to have a lot of different warehouses where your single objects are stored, I would say, or single rows, I would say. We have frames and doors and tires in that example, and each table represents a warehouse where the stuff is in, and we have to take we need some information to create a whole object so what if we need a car? So all the information are basically not part of the warehouse itself. So the frame, for example, doesn't know where to find the doors and where to find the seats, for example. You need some constraints in the database, and the constraints are only working on the database side. And for us as a developer, we can use that constraints within our code. And I think, all over, that's not the best structure in my opinion. It worked for a long time, but I think it's time to change that a little bit. And in my opinion, it makes much more sense to create objects which contains the whole object itself, and also it's important that each object contains the informations where to find the tires, the seats, the doors, and so on within the object itself. That's important. And when you take an object, and as I said, this is kind of like a root object, that is the main entrance to the car. And when you go through the car, you see all the parts which belongs to the car. And I think that's quite understandable. And for that reason, as I said, there are some things in a relational model which are not the best. The data within the table are incomplete. We don't have the information of the tires and doors itself within the table. We only have IDs within the tables. The informations about relations are absolutely necessary. That's for sure. Otherwise, we would not know how to combine all these informations together. In the database, the informations, or as I said, the constraints within the database, are not that helpful. They are only helpful for the database itself to keep the database consistent. But they are not helpful for the developer itself. Whenever you write an SQL, for example, you have to define those constraints again and again within your inner join, left join, or something like that. And that means the constraints are not helpful for the developer. You have to do that again and again. And also, especially for the Hibernate mapping, you have to do that again and again. And that's the different. A graph looks like the real world, I would say. The relations are directly defined within the node, and one object represents a whole car with all informations in it. And let's have a short look to an example project I created yesterday, just to show you the differences between the relational world and MicroStream itself. So there is one project which is called car migration. It's not important for you, just lean back and have a look. We have some objects in here, and let's start with the domain objects itself. So let's imagine we have a company, and there are we have some customers, and of course the customers, or these are our customers, and the customers belongs to companies, and these companies or customers have some orders with the header, the order header, and the order detail. We all know that structure, and we have products, of course. And now when we order some customers, then we will see code like this. So I think every one of you knows that the Hibernate annotations, which are needed to work with the database itself for the data mapping, you can see the many to one and so on. And basically this structure, we are totally fine with that structure, but we don't have, we have to load the data all the time. And the differences to the MicroStream, or whenever people ask us how to create the structure within MicroStream, let's do that. Let's find a way to store the data within MicroStream. So let's imagine this is the root object we talked about. And the only thing we have to do is to create the structure which is needed to store the data. Or let's imagine you have to create a cache for your database. Then you have to find a solution to store all the data from the relational database to your RAM. And therefore, we need some collections to carry the data within the root object. And this is like I did it before in the example before. Let's say private, and let's use a list of customers. Let's call it customers is new array list. And this is how it works with MicroStream. It's just the same. You can do it one by one. That is, you can use your objects which are used within Hibernate or also with relational databases, and mostly they are the same. And only in some special parts they are different, but mostly the same. And maybe let's have a look to the customer. You can see here, company is part of the customer in that case. So we wouldn't need to have a list of companies. So because all the companies are part of the customer, so there is no company collection needed to store the data, because whenever we store the customer, we also store the company behind the scenes. So that means we don't need a list of companies. But what about the products? Let's say, or what about the orders? Let's check where the orders are stored. Okay, not within the customer. So let's try to open the company. No, we don't have any orders here. So that means the order itself. Okay, let's change that. Okay, the order itself, here we have the order object, and the order object contains the data to the customer. So, and that means, okay, then we need a list of orders, right? To store all the orders. So we need another one here to store the orders. Now, order is the main object, and let's call this orders. Import. Which one is the right one? MicroStream. Yeah, this one. Okay, so we have the orders here, and the orders contains the order details, right? Yeah, here it is. The order contains a list of order details, and the order detail should contain a product. And so we have our products in place. But let's talk about that a little bit later. So that means for now, we need only two different collections to store all the data of our relational database. But let's jump back to the presentation. Some consideration regarding the data model. So let's talk about a car and the brand, which is many-to-one relation. That means one car, or a car can have only one brand, but each brand can have multiple cars. Okay, I think that's really straightforward. So you would be able to store the data like this. We have brand on the left-hand side and cars on the right side, and we have a list of cars within the brand. You will be able to store the data like this. But you will also be able to store the data like this. So we have the brand, or without any information. The same on the left side, we have the car without any information to the brand. And we have a brand in the car itself. That could be possible. Or you have something like that. We call that bidirectional. We have both information on both sides. So we have a list of cars in the brand object, and we have brand in the car object. I would say it's definitely up to you how to create these objects. In some parts, it might be more useful to have that bidirectional approach, especially you have to look to your business logic. It's more important to design your object model for your later business logic to work with that, or to fit to your business logic, I would say. Just create the model you need for your application itself. And if it makes sense to have both information on both sides, it's totally okay. Okay, yeah. The important thing is you have to take care by yourself to keep it consistent, right? So, for example, when you add a car to this list here, on the other hand, you have to add the right brand to the car itself. So that is, you have to take care, or yeah, that's important, because you, so otherwise you have some inconsistencies in your database. You can do this, but you have to take care about consistency in that case. Okay, another idea. Is it possible to have a car without a brand? That is also a good question. Let's have a look to this example here. We have a car on the left side, we have a brand here and a list of cars. Is it possible to have a car without a brand? I would say no, it's not possible, because if a car doesn't have a brand, it's not possible to have that in that list. Otherwise, the car has a brand. So, but what about this? Yeah, in that case, it's possible to have a car without a brand. But yeah, it's all the time an interesting question to ask. Is it possible, or does it make sense to have an object in my object graph, or to have a car in my object graph without a brand? Is it possible in the reality to have a car without a brand? No, I guess not. And also, it's the same in your data structure. And that is really important, because when the people ask us, what is the best data structure for MicroStream? And I always have to say, what is the best data structure for your application? Just decide it for your application, for your type of application. Whatever you need, whatever your, if you need performance, if you need, 1,000 possibilities in that case. And I think that's one of the biggest advantages of MicroStream, not to have a data structure related to your relational database. You have to use a data structure for your application. That makes much more sense than to create a structure to your database itself, or to the storage itself. What about this? In a lot of cases, the data structure influences also the UI. Or so that means whenever we use, or let's say we have a form with, oh, these are the German words, sorry for that, but that is a form for price and category and product, I would say. And then we have the category here, and it's a combo box. And so it's necessary to have a list of categories available to choose one of that. And that's important, because in somewhere I have to get a list of all my categories. And yeah, that's important to know. And your data structure influences, for example, the framework you use, the UI framework you use. Maybe it's no longer usable, or some features of the UI framework are no longer usable, or the way to store the object behind the form is totally different. And if you only have the brand, how to get all products of a brand? Yeah, that's also interesting, how to get the data out of it. Let's have a look to that later. Oh, this is also interesting. Find the category of a product. Let's say we have all the categories. We have a list of categories, and the category contains a list of products, which is a quite valid structure, but it's quite hard to get the category of one product. So that means we have to do things like that. We have to say, okay, let's go through the categories and just give me the category of the product I hand over here and say, let's find first. That would fit great for this case. If we only have one product in a UI, that will work totally. But what about this? When we have a list of products and we have to show the category here, this would not work in that case, because the performance would be quite a mess, I would say. Yeah, you have to consider that. How to create the data model. Bidirectionals, we already talked about that. Some of you would say that is a redundancy, and yeah, mostly it is. But especially with MicroStream, does it need more memory in the RAM when we have those bidirectionals? And basically, yes, but not for the data itself, but for the references. Yeah, that means let's imagine we have, let's say we have products, and we have each product contains a category. And as I said, sometimes you would need a list of all categories. And when you delete a product with the last category, you will lose that category for all the other possible products you will have, for example. And for that reason, you have to have another list of categories to store your categories itself, to have one reference at least. So, and for that reason, it's not, you would not need the RAM for the data itself, but for the reference, of course. Okay, and in the end, of course, a huge amount of references can also lead to a huge amount of RAM. Yeah, that's also important. Keep in mind, MicroStream is an in-memory database. Okay, so let's jump back to that example here. We created some lists here, customers and orders. And now an important question is, what happened when we have, let's say we have a product, and as I said, the products are stored within the order details, right? So when we jump to the order details, we see the product here. So, but now the important question is, what happened when we delete the last order, which contains the last product? Then we will lose that product because we deleted the last reference to that product object. And for that reason, we need a list of products.
I would have one question here.
Of course.
Would it make sense from a structure standpoint to create a second root object? So basically you have one for the sales only, MicroStream sales only, and one for the as a data holder, let's say, for all available products and so?
Could be possible, yes, but then you have to do some mapping stuff between those two objects, right? So I don't know if I get it right. Can you do some more explanation?
Okay, I mean, for me, the MicroStream sales is the root object, right? Which holds the reference to, in this case, the customer or the order the customers did.
Okay.
And we don't want to lose access to the products because products can exist without any order happen.
Yeah, right.
So my question was if it would be possible to create a second root class, let's call product holder or product data holder that just holds the list of products, which then can be assigned.
Okay, now I got it. So yeah, it's possible to have multiple roots. That's possible basically. But I didn't use it in the past, and I'm not sure if that. I think that's not necessary to do that. It wouldn't change anything. I would say basically you have, yeah, of course it's much more separated, but it makes no differences in the end. So if you have a list of products here, that you will be totally fine. I think that's the answer from my side. I never used the second or third root within a storage, but it's definitely possible. So if you want, but yeah, you don't have any advantages in that case. Is that okay for you?
Yeah, all good. Thank you.
Okay, but for sure we need a list of products. And this is the point where some people ask, okay, now it doubles the RAM, maybe because we have products here and we have products as a part of the order details, but that isn't the case, because it's only a reference to the product itself, and the product object itself exists only once, and all the others are references to that product. And that's why it's totally fine to have that, to double, as I said, the products in that case, and to reference to this product list. Okay, we have customers, we have orders. Maybe we have to take care about the companies. What about the companies? When we delete a customer, and I think it's in some parts it's the same. When we delete a customer, do we need a list of companies in the end? And yeah, maybe and as I said, it's up to you. Just create a list of companies if you want, or if you need. Company, I think this would be the right one. Okay, and then we have companies here. And again, as I said, the data structure is totally up to you. And if you need it, then you have to create this. But there are some more opportunities, and we talk about that opportunities later on. You don't need to have a list, for example. You can use hash maps or sets. You can use any collection which is available within the JDK or within Java. And in some parts, hash maps are quite useful in combination with MicroStream. But let's talk about that later when we come to the lazy loading part of MicroStream. But I think that's a good example to see how to design an object graph. Basically, you have to take care about the collections itself to store the data, but the data are the objects itself, or the entities itself, are quite similar, which are created for Hibernate, for example. And most of the time you can use them one by one, I would say. Only when it comes to some special stuff, you have to change the structure, but let's talk about that a little bit later or tomorrow. Okay, any question to the data structure or the data model itself, or some more adds from your side?
And this is a question related to this MicroStream sales. Does it mean that the MicroStream sales will be the root object, and all of these sub-objects will be stored within the root? So we can access them.
Yes, that's right.
Searching. Okay. Okay.
That is, I think the root is the main entrance, I would say. And these collections here are the data holder, or the, yeah, it's the structure itself to keep the data.
And if we want to search some data within these substructures, then we will iterate through all the structures.
That's right. Yeah.
Okay.
And we use the Java 8 streams to iterate through a list, for example, thing. But I also created a lot of examples for tomorrow when we talk about the streams API and how to use it. And yeah. Maybe that would answer the question for you then.
Yeah, so this is the recommended way to have a flat structure and accessible from with everything.
Mm-hmm. Yeah, definitely. So, and there are not only, you can use whatever you want, not only lists. In some cases, it makes sense to store some more data to the root. So as I said, MicroStream sales, which is maybe a business object, let's call it like this, it could have much more information. For example, let's say private string name of my company. So just to make it more understandable for you, it's a business object and it contains all the data which is needed for my business. And this is how the data structure grows more and more. And the only restriction I would recommend is don't use any third-party objects in that case. Yeah, that is quite a mess if you increase the version of the third-party library and then the object change. Then you have to do some migration in the end, and that could be quite difficult to do that.
Okay, thank you.
And I think the worst case would be if the third-party framework deletes the entity which is used within your application. Then you have the problem that the object is no longer available, because when we have a short look to the data folder itself, that could also be interesting for you. Let's jump to the persistent type dictionary, and we already talked about this. So every object which is stored within MicroStream is also is available here. You can see that here we have that. For example, this is my customer object, which is used in that storage, and also the third-party object will be part of the persistent type dictionary with all the information in it. And you see it is referenced by the class path. And when you start the application itself, MicroStream tries to find this object within the class path, and when it's no longer available, you will have, or you will be in trouble. Then I would say you have to do some migration stuff in here. So, and that's why I said I would not recommend to store third-party objects within MicroStream. Okay.
I just have a small clarification, a really small one. You said that basically the list of products would hold the actual products in this case. So let's say we have a book like the Bible or something like this, and the orders would just store the reference to the product, which means if the product name gets changed, it automatically basically is also changed for all the orders.
Yeah, that's right. You have to take care about that. And that's also the reason why I choose a different strategy here. Within the order details, I used the product as a normal reference, but I added the price as an additional field, because basically I could do the price, or I could add the price to the product too, but that makes no sense, because when the price changes, it also changes for all the details. Yeah, that's exactly what you said.
Okay, thank you.
You have to take care about that. Then you have to create some duplicates or something like that. It's up to you how to design your object graph. But I think it's the same. That is also the same on relational databases, right? I think when you use a foreign key constraint to a product, for example, I think that's the same problem on other databases. Okay, some more questions. Okay, before we go to lunch, I want to give you a short introduction how to use Micronaut, because we need Micronaut, or we will use Micronaut a lot in the following project and examples and so on. And therefore, I want to show you how to handle Micronaut projects within your IDE. And the first step to have that, just visit this this homepage of Micronaut .io launch. So I will send you that URL. Micronaut.io launch. Basically, what is Micronaut? Micronaut is a microservice framework, I would say, especially to provide REST endpoints. And that's why I use Micronaut, because in some parts we want to store data, we want to load data, we want to edit or update some data within MicroStream. And I would need some, otherwise I have to create some UIs or something like that. I think it's much easier to use REST endpoints for that. And that's the reason why I use Micronaut. So when you visit this site, you will see that configuration, configuration wizard. So you don't have to choose Micronaut, that you can keep it as it is. You choose a Java version which fits best for you. The language is Java. Then create a name, the name of your application. In my opinion, I would use Maven, but it's also possible for you, if you work with Gradle, then use Gradle in your part. That's totally up to you. Let's create a name. Let's say demo application, and enter your base package. In my case, it would be 1.microstream. 1.microstream. Let's keep JUnit. Everything is okay. We have the name, we have Maven, Java, everything is, that is right. And then you can say, okay, create the project and download as a zip, and it will create an application for you, which looks like this. It's just a Maven application, and this you will be able to import this Maven application to your IDE, and then you can do some coding stuff. And I did this, and I have these are those applications. Let's go to the step-by-step configuration and switch the branch. Let's move to the very beginning branch here. And this is how the application looks like. You will get a really straightforward small Java Maven application. The only thing you will see is the application java.class. And of course, there are some more dependencies within the POM XML, especially the Micronaut stuff is in it. And you see the application. As I said, there is an application YAML file within the project itself and a logback, and that's all. And the most important thing is you have to enable the annotation processing of your IDE. So in my case, in Eclipse, there is, you will find it on the preferences, and you can search for annotation processing. And in my case, I have set it to experimental. And this is necessary to get it run. So, and after that, when you have the project, you only have to say, okay, run as Java application. And then you should see the Micronaut part in your console. And then it will show you, give me just, it will show, this is the URL where the requests are reachable. So in my case, it's localhost 8080. But let's have a look later on. So you can just try it out. Just use the wizard, download an application and import this application to your project management or to your IDE, and try to get it run. Yeah, that is basically how it works. But in the end, you will get the URLs to my GitHub repositories and so on. And you don't have to download the Micronaut applications by yourself. So you can just pull or clone the projects from my repository and use this projects as example project to code along with me, I think. Okay, but basically this is how it works. Just use the wizard, create an application, import this application, and then you have that application class here. Let's choose run as Java application, and then you will see the Micronaut here. And just keep in mind that you have to enable the annotation processing. That is necessary. And let's do a small example with this application here. So when I switch the branch, so no worries, we will do that later. Let's say team switch to the last branch. Then you will see there are some more classes in it, but we will do all that stuff together. Let's say we have a book controller here. And then you can see here are the different endpoints we need. And when we now start the application itself, so we will be able to do some calls via browser. So let's say, okay, localhost 8080, and then say books and create. Yeah, that is the call. When you see here, this is the controller /books and /create, and that is the same we call here. And then you can see that here. Let's just say what happened there. Okay. One moment. There is still a storage within the project which doesn't fit to the thing. Okay, now start it again. Let's run books create, and now you can see books successfully created. And when we now call books, you can see the books in the end. This is how we are working in the next 2 days, and that's why I give that small introduction to you, just that you are able to code along with me through the different example projects. Okay. So does this work for you? Some of you tried that with Micronaut and tried to get it run?
I mean, personally, I'm using IntelliJ and it runs without the annotation processing, but I just wanted to know what the settings for the annotation processing were again, because there I zoned out a bit.
It should be a Maven. It should be a Maven property, and in my case, I found it on Maven and then annotation processing, and I think in the Eclipse IDE there must be something similar to that.
Yes, there is something similar, also under Maven and annotation processing. But on the other hand, I have problems starting the application. It simply does not start. Okay, maybe you have to choose a different port, because it starts normally on 8080, but you are able to change that by give me just a second. I have to find one moment. Okay, there is. When you go to the application itself, and there is the application YAML file, and here you have to add another, let's say, something I'm not quite sure, server, and then you say it looks a bit different for me. I have a netty enters also.
A netty?
Yeah, netty. I'll post on the chat what I have.
Yeah.
Is how it looks like.
Ah, okay. I've never seen that before, but so I would say basically you would need a netty, but yeah, maybe I don't have that.
Strange.
Or maybe it's new on the newest version of Micronaut. Could be the case. But the question is, did you get an error message or something?
Yes, like that? I got some error message, but I didn't have a time to analyze it.
Ah, okay. Just to check if this is working. Java application. So something is still missing here. I think it's more like that. Every time the same. Let's see. Like this should be. Ah, okay, that's a good point. Yeah, thank you. Let's do it like this. Port equals. No, but like this, right? So or server.port. This, I guess. Mm-hmm. Yeah, this is working. So if you have to change the port of the application itself, just type this server.port 8070. This should do the trick. Most of, maybe you should try this with my application itself. I can forward you the, let's give it a try with one application from my GitHub repository. Let's use the first one, is the configuration one. Let me just double check which is the next topic for today. So configuration, okay. Getting started, step-by-step configuration. Okay, so configuration step. Okay, here we are. Okay, so this is the first project we are working on after lunch. So just clone this project to your IDE.
You are still sharing your Notepad++.
Ah, okay. Sorry. I posted it in the chat. Just have a look to the chat.
Yeah. Okay.
Can you show once more how do you start this Micronaut app?
Just go to the application class.
Yes.
And in my case, you just run as Java application.
Java application. Okay.
You could also do it the Micronaut way. Let's jump back to the launch page. When you click on, when you can also see the commands, and this should also be possible. Oh, give me just a second to download zip. Yeah, to launch that application, you could also use that command, Micronaut run, and on the project package or within the project.
Okay.
That should also work. But I mostly do that with the run as Java application. And oh, what happens there? Ah, it's changed something in the YAML file, maybe. And so, okay. Yeah, this is making relevant a note here. Yeah, in the CLI, yeah. You can use the CLI to use the command. I try to find it out how to change the port first. So I don't know why it's server port equals. Can you try? Sure. Server.
Try to move server.port under the application.
Like
Micronaut server.port.
Like this, Micronaut.
Yeah, you have Micronaut as a root node. Okay, so just move.
Yeah. Like this, right?
Yeah. Try this one. And equals is should be this.
Okay, let's try this. Micronaut server port. Yes, I tried. I tried this before, but
yeah, maybe change the corner.
This should also do the trick, right? So give me. Yeah, I did this 1,000 times before, but I could not remember how to use it again. So now we have 8080. Okay. So Micronaut server. Application. But wait a second. This is moment. I will check that during the lunch, and I will give it to you after lunch. I think that would be best. Yeah, thank you very much. I have to check the documentation. Maybe. Yeah, I did this in the same way. Micronaut server. I think the problem is that I used a tab instead of. But that's the same. Server. Port. Yeah, for sure. Okay, if there are any questions, feel free to ask. You can also ask during lunch. I will be back a little bit earlier so I can write down the answer into the chat. I will also try to find out how to change the port. Hopefully that will work. And then we can start after lunch with a new Micronaut project to do all the configuration stuff again together. And then we have to create a CRUD project to all the insert and updates and stuff like that. We will do all that stuff after lunch. Then we have our example project, and that's all for today. So I double checked all my system properties, and actually, I'm afraid I changed the wrong application YAML file for the wrong project. So that was the reason why this wasn't working. So let me share my screen again. Okay, screen one. Okay, here we are. So this should do the trick basically. So to change the server port of the Micronaut application, this is okay. These are just empty or white spaces here. Then you say server and another 2 white spaces or blanks say port, and then you can choose 8070. And it's the same for starting the application itself. You can start the application by using like run as Java application, but it's the same when you say, okay, just get to the CLI like this. Then you go to your project. Let me just show you the directory. Should looks like this. And then you can say mvnv, nvnw, and then nn run. And then the Micronaut application will also start from the CLI. And that is totally the same. It's up to you to start the application. Okay, just to clarify those changes, I also checked the netty configuration of your Micronaut version. This is part of the newest version of Micronaut, so you can keep it as it is. Let it just add the if you need, just add the port configuration, but this netty part can stay inside the YAML file. That's a default configuration of Micronaut. Yeah, that also worked. So yeah, okay. But I think it's not that important to get a basic Micronaut project running. I will share the project, the following project again. That is the URL. So I think it's more important to check out this project from my GitHub, because that is the next project we are working on. But this is also a Micronaut project, but on a previous version. So that's also the reason why I don't have this netty configuration stuff inside the YAML file. And we can work together on this application on the branch. Let's take the branch beginning. Just give me a small thumbs up when you are ready to check out the project. So during the launch, we had also a question regarding to use the MicroStream DB, MicroStream cache, MicroStream REST configurations within the Micronaut configuration. Why not to use this? Okay, the answer is, so basically there is a MicroStream integration for Micronaut already in place, also for Helidon and some more microservice frameworks. But for the fundamentals training, I think that it makes more sense to use the basic stuff, the basic configuration, for better understanding how MicroStream works. So that's the reason why we don't use the MicroStream or Micronaut integration in that training. But there is also an example available on the Micronaut documentation, how to configure MicroStream with the Micronaut integration. Okay, to start, you should stay on the beginning branch. That is not needed anymore. So let's check the POM XML. Should be empty as well. That means there is no MicroStream dependency in it. So that is okay. That is the point we can start.
How exactly do I rebase to the beginning?
Sorry.
How exactly do I rebase to the beginning? So I have to go to the project, then right click, then you go to team or some
team. Yes, exactly.
Team, and
team.
then it's switch to.
And then you can say, let's start at the beginning. This is the first branch. I added several steps, as you can see here, to for the project configuration. But let's start on the beginning.
Okay, I do not have this, but
okay. Just check it out. So team, then switch to, and then you can choose others. And then you have to choose the remote tracking ones, and here you will find that, because maybe
okay, yeah,
they are only available on the remote, and here you can choose the beginning then.
Okay, thank you.
Okay, so okay, so the first thing we have to do is to add some dependencies, and especially for this project, we need two different dependencies. The first one, so for that, just go to the POM XML file, and we need the two dependencies. I copy pasted here. So it's the first one is the storage embedded. I would say this is the main MicroStream dependency. And if you want to do some further configurations, you will need the MicroStream storage embedded configuration dependency also. I will copy this also to the chat. That makes it easier for you. So then you can copy paste the dependencies from the chat. As I said, you need the main dependency, storage embedded, and also the dependency embedded configuration to do some further configuration stuff. Also, the way we initialize the storage manager will be a little bit different to the first example, and for that reason we need the configuration also. Okay, so the next step would be to create a class where the storage manager can be initialized. And for that, I create a new package on one.microstream. And let's call that package, yeah, let's call it storage. Let's say storage. And inside this package, let's create a class which is called DB. So that will be a static class with static variables in it to get access to the storage manager and also get access to the data root. And we will call that DB class all the time when we want to get access to MicroStream. So again, just create a package, call it storage, and inside this package, create a class which is named DB. Okay, within that class, we need the two, as I said, the two most important variables or fields, I would say. We say, okay, public, static, oh, no, that's not, so let's say public, static, and then we call it embedded. Embedded storage manager, where it is. Okay, I see. Yeah, storage manager, and we call it storage manager. Okay, so as I said, just create an object which is called embedded storage manager. It's the most important object or the central object of MicroStream. And let's call it storage manager. So then we need our root object. Let's create the root object in the same folder like the DB class. So let's jump back to the storage package. Let's create another class, and let's call this class just data root. And in that case, we use just a technical object to carry our collections and so on. Let's call it data root. We don't need any fields in it, not yet. We just create this data root class to be able to initialize that object directly here. So let's say public, static, and yeah, I would say, let's say final also. Final, static, data root equals, oh, we need the name, root equals new data root. Okay, now let's add a static initializer block. And now let's initialize the storage manager a little bit different to the first approach. So let's say storage manager equals, and now we can use the embedded storage embedded storage configuration object. And now let's use that builder pattern. So let's say, okay, we start on the configuration, say .builder, and that gives us the possibility to set a lot of different, or to do a lot of different configurations. And the first one would be set the storage directory. So that means the URL of the path where the data will be. Let's call this data. and then say set. Just for an example, let's say channel count and set this to 2. I will explain you later what does that mean. Set storage directory data and set channel count 2. And now are two important methods. The first one is create embedded storage foundation. And then let's say create embedded storage manager. And after that we say start. And this is how it works. So and this is how it works all the time. So first we have the configuration here, and out of that configuration we create an object which is called foundation. And out of a foundation, we are able to create the storage manager itself. But there is one parameter missing. Let's add the root to that embedded storage manager. That's also important because the storage manager has to know which is the root entry object to the graph, I would say. So, and this is the second possibility to instantiate an embedded storage manager. There are many more, but we talk about that later, a little bit later. I think, in my opinion, this is the most recommended one. The first one we have seen is a very short version. It's a little bit limited to the amount of configuration you can do, but this one, I think that's the most powerful one. There is another one which is a very complicated one, but that enables you to adjust everything of the storage itself. And I think the most recommended one is this one. And for this one, you will need also the configuration dependency. That is the reason why we used it. Okay, let's summarize that a little bit. Oh, that is not what I want. So that's this. Okay. So we have our storage manager. We have the root, which is in this case, which is just a technical root. It's not part of our data structure or of our business. It's not a business object, I would say. It's just a technical root entrance object. And to initialize the storage manager, we use the builder pattern and let's say set storage directory data. There is also another one which is called set storage directory in user home. Yeah, this one. This will store the data in your user home. Yeah, most of the time, we use environment variables to set up the storage or to hand over the path to the application itself. But it could also be part of the YAML file or something like that. That is totally up to you how to hand over the information. Another interesting part is, or maybe I can show you another configuration, something like that. Set backup directory, for example. MicroStream is able to write down a mirror on every time you write in the normal storage. Also, the mirror will be written, and in the end, and that is why there is a set backup directory. Then you can hand over another URL, or for example, also an S3 bucket, for example, to write down that storage mirror for some backup purposes, I would say. But let's come to that later. The channel count configuration is MicroStream is able to write down or to use multiple IO threads to write down the files to the hard disk. So whenever you have to write down huge files, for example, sometimes it makes sense to split up the UI threads. And for that, you are able to create multiple folders. Then you will have the channel 0 folder, that is the default one. And when you set channel count 2, then you will get 2 channel folders. You will see that in the end when we start the application. But basically, these are the input-output threads to write down files to the hard disk. Okay, so then we create the embedded storage foundation, the embedded storage manager, use the root as parameter, and then we say start. Okay, so let me check if we created everything. Data root is already in place. Okay. Any questions so far to the setup or the...
Maybe I have a question because I joined it right now and I missed the first initial steps. Can it be downloaded from GitHub?
Yeah, so I can post the URL again. Give me just a second. Step-by-step configuration. So here's the link again in the chat. And you can start on the, let's move to another branch. Let's move to the, let's say, team and switch. Let's move to create a MicroStream instance class done. This is the branch number 4, I would say. I would discard the changes, and then you will have the same setup like we do. Maybe there are some more. No, so I think it's the same. Okay, so one moment. Save. Changes, delete that. Okay. Don't need that anymore. Okay, give me just a second. So just to double check if source main. Okay. No, don't push that. Switch to, let's go to this one just to ensure I'm on the right branch because I missed the DB class in it. Okay, so okay, understand. So that is a little bit different. So the DB class and the data root are not part of the storage package. That confuses me a little bit. So, but it should be the same. You should have the DB class in place. Of course, with the set channel count is missing, but that is not important. It's just to show you that you will be able to configure more stuff here, but it should look like this when you choose the branch number 4. Okay. So I will wait a little bit.
Should we all change to branch 4 or?
Yeah, but you can do that. That's, yeah, it's up to you. You don't have to, but just for the future, if you want to see all that stuff, it's, yeah, it makes no differences. You can also stay on that branch and code that along with me. So I will also delete that storage. So in my case, okay, so another package we need here is the domain package. The domain package contains all the domain classes. And especially in this case, we create two of them. One is the author object and one is a book object. So that means let's create the two objects. Let's say we have an author object which contains 3 fields. Let's say private string mail. Yeah, we already did that. Mail, it's kind of like the same like the custom object. In the end, we have mail, first name and last name. So nothing special. Just create a constructor for the fields. That's it. And also let's create some get and set methods. That's all we need for the author. And we have the same on the second object, which is the book. I think the book is more important. Let's say book. And the book object contains also private string an ISBN, which is the identifier of a book. And let's say we have another string for the title or for the name. Let's call it name. And of course, we need another one. Each book has an author. That's all we need for the book. Also, just create constructors for the fields and also get and set methods. So, and the only thing we have to do, we have to register these objects to store it to the root object. And in that case, it's the data root here. And let's add a list of books. Let's say private final list of books. Book new array list. Yeah, should import the right one, that we have a list of books here. Then we say get, we need a get method. Yeah, get book. Books. Yeah, that's better. Just a small example. And that is also a reason why I use Micronaut a lot for the trainings, because a lot of people ask me, okay, how to use MicroStream with multiple applications. So maybe yes, a lot of company uses one database for multiple application, and they give them access to the database and they do some SQL stuff and so on. A good or a best practice is actually to use MicroStream as a data provider within a Micronaut application. So, and that is also the reason most of our users create a Micronaut application, which is the data provider, and it provides the data via REST endpoints to many different other applications. And yeah, of course, when you use microservices and so on, I think that's a really straightforward way to do that, to provide data. We also created some Micronaut applications as AWS Lambda service to provide the data from Lambdas then. That could also be a great approach for your microservice architecture. Okay, so, but yeah, for now we are now ready. So we created an author class and a book class, and we registered the books in the data root, and that's all we have to do inside that branch. Okay, so let's move on to the last, and especially for Micronaut, the important classes. It's the controller class. So let's create another package here, and let's call it controller. Let's create a controller package here. And inside that package, create a class which is called, I think, book controller. Give me to double check that. Yeah. Book controller. And here we have to do some Micronaut specific stuff. So that means we have to add the controller annotation here. So let's say add, oh, just use that add controller, and let's say the URL to that class is slash, and let's say books. That is the entrance to that endpoints, controller books. And then we need two methods. Let's call it public method, and it returns an HTTP method, which is the Micronaut HTTP response. Give me just a second. It's the response. Yeah, but it's the same. IO Micronaut HTTP response, I guess. And let's call it create books. It's just a helper method to create books that we can.
Shouldn't it be type-sized?
Yeah, to string. You're right. It should be typed to string. And there is another one, and let's return not an HTTP response, just return a list directly to make it much more easier. Yeah, it's not. I know that it's not the. I would say that's not the best practice to implement those REST interfaces, but it's just for training, and I think that's totally okay. It's only the Micronaut stuff, and it's only for training purposes. So create books should never be a GET request, and we will add the GET annotation. But oh, come on. I do this because of using the browser. So instead we had to use Postman, for example. and that makes things more complicated. And that's the reason why I only use get here in that case. Let's say get, and then at the URL part, let's say /create. Normally we would use a put instead of a get, of course, but yeah, as I said, that's only for training purposes. And we use the same here. We also use a get here. So that means whenever we call localhost.8080/books, we step into this one. And when we say /books/create, we step into this one. Okay, I will copy you some lines of code that makes things a little bit easier for you.
You still need to rename the second method.
Oh yeah, you're
It's not
right.
great.
So let's, yeah, I called it get books. So keep it simple. We have to import the book. Okay, here we are. So I just copy a line, just a few lines of code. Just insert these lines. You don't have to type that much. I think that's normal instantiation of some objects with the constructors. So in that case, we use author. We use 2 different author objects and 4 different book objects with different ISBNs and so on. And now we have the interesting part, how to store the data. So first we go to the DB class and say, okay, DB class, give me the root and give me the books out of the root. And then I can say add all. In this case, we can use add all. And yeah, let's use arrays or collection utils. It's up to you. Let's say arrays dot as list, and then we are able to hand over book and book 2 and book 3 and book 4. There is another possibility to do that. There is a collection utils method already. Yeah, there are some collection utils on Micronaut or list of 1,000 different possibilities to do that. The important thing is that the point we have to store, and for that we use the storage manager dot store. And remember, what do you think? What do we have to store? db.root.getBooks, because we changed the collection. So that means we added some elements to the collection. That means we changed the collection, and then we have to store the collection. So, and in the end, we have to return the HTTP response. And let's say .ok, book successfully created. Only created. And the second method is also quite easy. Let's say return db.root.getBooks. get books. That's easy. So let's double check if we have everything in it. We have the data root, we have the two objects. Yeah, let's try it out. Let's start the application. So where is the application itself? Here it is. Run as Java application. Okay, seems good so far. Oh, come on, that is my browser. So let's call books. Okay, I will get an empty result. In that case, it's the same here. You see the MicroStream storage is initialized. So that means let's have a look there. So embedded storage manager initialized, everything seems to be great. Also, when we refresh the project itself, we see the data folder here with channel 0. In your case, there should be 2 channel folders because you set the configuration to 2. And now let's create some books /create. Books successfully created. And when we now call books, you see the list of books. Works like a charm. How about you? Does it work on your side? Any problems so far?
Yeah, it works.
Ah,
It works.
that is great. Okay, great. Yeah, you can just skip all these parts you have entered. As I said, you will be able to just switch to the next branch, also to branch number 6.
Can you wait a minute?
For me, it does not work.
By me, I am getting page not found, even if I see in console, in Eclipse console, this Micronaut startup completed, server running at localhost, blah, blah.
Ah, okay. Did you activate the annotation processing stuff? Can you please double check?
Yes, probably.
Window preferences?
Maven annotation. Okay. Delegate.
Genau. You should enable, yeah, to experimental would do the.
Thank you.
I've activated and still it does not work. First, I don't see that many lines as you see here on the console. And while the get was working, I mean, I got an empty list, okay? The create does not work. I get a null pointer exception.
Ah, okay. So then you can just double check the part here. Maybe you missed something, or you missed the annotation here. That could also be possible.
No, I have both annotation. I have controller. I have get. I mean, with 2 gets. Create.
Controller.
And where is this null pointer exception coming from? Controller or?
Which line do you have?
It comes from line 31. Line 31 is DB storage manager store. DB root get books.
Okay. Ah, okay. Let's have a look to the DB class. Can you please check
if you have a static on the?
Yeah, maybe the start is missing.
Static is indeed missing. Yes.
Ah, okay, and also static, yes.
Yep.
then you get the null pointer on the storage manager, right?
Yeah. Okay, thanks.
You're welcome. So if you have any question, feel free to ask. It's not that complicated, to be honest, but I think most of the stuff is Micronaut stuff, and only the small parts here are parts of MicroStream.
I got again a strange error message on the create syntax error JSON pass unexpected character at line 1.
Okay.
The raw data says book successfully created. Okay, but it cannot interpret. It doesn't interpret this as a JSON. Okay. Yeah, but books are created and I get them. Everything is fine. Thanks.
Okay. Okay, that was another small example, I would say. Now we get a little bit deeper into it, especially the different methods, how MicroStream can be initialized. There are 2 more, I would say. And then we have the last example for today are some more CRUD operations. But first, let's dive into the different ways to initialize this embedded storage manager. And for that reason, we switch to another project. I prepared one. Just a moment to find it. Step by step. That's the configuration. Okay. No. Okay, the link is in the chat.
May I ask you something?
Of course.
On the very left part, you have under the Maven dependencies, you have the data. And I don't have it.
Ah, okay.
Between Maven dependencies and target.
Can you just try to refresh your project? Just use the refresh. Maybe it's hiding.
Okay, thanks. Yeah. Now I have it. Thanks.
And you should also have a 2-channel folder.
I have 2 channels. Yes.
Okay. Yeah. Sorry. So there is one interesting thing I would say. Yeah. The important thing is that when you use that channel stuff here, I would recommend most of the time channel 1 is totally fine. You will be totally fine with channel 1. There are some special, when you have a very special object graph, for example, then maybe you will need more channels, but you have to try out which solution is faster. But the important thing is just increase channels only by by 2. So that means we have 1 channel, 2, 4, 8, and so on. And there is another thing you have to need is that you will not be able to change the channel afterwards. So whenever you want to change from, let's say, 4 channels to 2 back, it is basically not possible. You have to migrate your storage. it's not a big deal to migrate because you will be able to create a second storage manager instance within your project with the new amount of channels, and then copy just the whole root object to the second storage manager. That's how it works, the migration. But you will not be able to change the amount of channels on the fly, I would say. You have to migrate the storage for that. Okay, but this is more a topic for the advanced in the end. Okay, so yeah, I posted you the new configuration project. So let's close this on my side. Yeah, and I think it makes sense to jump directly to branch. Let's say team, switch to, and let's say other. And there is one which is called configurations done. I think we jump directly to the finished branch, and this is what I'm talked about. So you will be able to create multiple storage manager within one project. That is totally okay. We have, for each storage manager, we have one root in that case. And after that, you see the different possibilities to initialize a storage manager. And we already talked about this one. We have seen that. That was the very first one, the easiest one, the short version, I would say. The second one, we also talked about this. That was that we used a few minutes ago with the builder pattern. Then let's say, yeah, this is what I've talked about, backup directory. You say set root. There is another possibility to add the root, many different ways to initialize. That could also be an interesting one to have all the configuration stuff within one MicroStream XML file, which is also based here. So that means I have an XML file here with some properties in it. As I said, storage directory, data, channel count 4. And this is the way like Micronaut loads the XML file and creates a resource out of it. And then I can hand over that resource and create, yeah, let's say, then always this is the same. This represents the configuration. Out of the configuration, we create a foundation, and out of the foundation, we create a storage manager, and we have to start it. That is the same. Yeah, possibility to use an XML file or YAML file or something like that.
I would have a question regarding the different root objects, basically. Is it allowed, or is this would it be an anti-pattern if basically the root 1 contains a book and root 2 also links to this book, reference to this book? Or should every root only have its own object?
Yes, that should be the case. Only every root should have its own objects, yes. But I'm not sure. I'm not totally sure if this is I have to double check this with Florian. Maybe that will work, but no, I think not, because the problem is when you have an object in root 1 and you initialize the storage manager, he will try to find an object which is not available because it's part of the storage manager 2. And maybe that leads to a problem, but I wouldn't do that. I wouldn't recommend that.
Okay.
But I have to double check. Yeah, I will double check this with Florian. Maybe we can do a small Q&A session for tomorrow. Let me just take a note of that. Take a note. So So that means how to say, use references in multiple root objects. And okay. Okay, got it. So hopefully we can answer this tomorrow. I'm pretty sure we can answer that tomorrow. Okay, so yeah, that's the XML way to initialize. Yeah, I want to show you also the part in the documentation that could also be interesting. All the stuff we do now is also part of the documentation. So here are the different. This is the short version. This is the external configuration. So that means you will be able to use XML, for example, here. You can use a Java ini file. YAML is also possible. Another one is this one. That this is the most complex one, I would say. Most of the time, I did not need this, but there are some really special configuration parts which are part of the advanced training. Then you will need this type of initialization. But yeah, I think it's also totally the same. In that case, we create a foundation and we add a configuration here, we do some configuration stuff here, and then we create a configuration. Also, this is the part of the configuration. And then, yeah, out of the foundation, we set the root, and then we create a storage manager. Again, basically, it's the same, but some adjustments or some configuration has to be, they have to be done on the configuration or on the foundation side. And that is the reason why we use that. But yeah, that's part of the advanced training. Most of the time, I would recommend to do it like this. I think that is the most powerful way to do that. And yeah, at the beginning, I used this a lot, but not since it makes more sense for me to hand over all that information via system properties or environment variables. I think this one is the best to use. Okay, any question to that XML part, maybe to the instantiation of or to the best practice or something like that? So any question from your side?
Yeah, the question related to channels.
Yeah.
You said that it should be power of 2. If you, let's say, set up, for example, 264 channels, is it good practice or bad practice? Or?
I would recommend you the part of the documentation. So I think whenever you need a multi-threaded way to write down your data to the hard disk, and you see any advantages to have multiple threads to write down, it makes sense to increase the amount of channels. But I've never seen 64, for example. I would say from my best practice part, I would say use 2 at the beginning if this is working great for you. To be honest, you won't, yeah, with all the normal type of data, you won't see any advantages in case of performance, for example. MicroStream is basically that fast that, yeah, the result, you wouldn't mention that. So it's a really special configuration for people who need that many I/O operations to the hard disk. But yeah, I've never used more than 4, to be honest. And I'm totally fine with that. But I have to say, it's up to you. Try it out with different configurations. What's the best for your data model? Maybe it's faster to use 2 or 4. In some parts, it could be slower to have multiple channels because the data is separated to the different channels, and then MicroStream has to collect the data out of all that 64 channels. I think that the result will be worse than to use a smaller amount of channels. But yeah, there are some detailed information regarding the channels. Here you will find some more detailed information regarding that. And there is another properties. I think that's channel count, number of threads, and number of directories used by the storage engine. And maybe there are some more deeper information. Using channels. No, that's it. In fact, that's it. The unity of thread. The I/O performance. So whenever I/O performance is important for you, but it's also the same to write the data, for example, to S3. When you use an AWS S3 bucket, for example, then these channels will also are affected because the number of connections threads to the different buckets could be helpful in some cases, yeah, to increase the number of channels.
Okay, so just playing with configuration and measurement.
Yeah, of course.
The correct one.
Yeah.
Okay. Thank you.
Okay, so let's jump back to the IDE. Okay, so I would say we have another, okay. So let's go to another example to talk a little bit more about the CRUD operations. I will post you the link again. And it's a project which is called CRUD operations. Here is the link. Check out that project. It's the same configuration like all the other projects, totally the same. And we're going to start on the branch. Team switch. Let's start directly on the master branch. So MicroStream CRUD demo. Directly on the master branch.
I will need some more seconds. You're still downloading it from GitHub.
Yeah, no problem. Here we have some deeper information. Thank you to Primo, right?
Yeah, you're welcome. There is a little drawing about the multi-threading.
Yeah, that's right. Some more detailed information there. Yeah. I can also move it to the front here. Oh, yeah, genau, here is it. But in the end, it's up to your data structure and just testing which one is faster. And I think that will do the trick. So especially on that page, there is another description, that housekeeping interval and that housekeeping time budget. That is also part of the advanced training. Marcus mentioned that already. These two values are the interval and the time budget for decreasing the storage, because every change will be attached, and this service takes care about to decrease the storage. And the interval says how often it happens, and the time budget is the time budget of the CPU, which is used for that housekeeping stuff. That's also the same. You have to measure that, and you have to test it, what fits best for you and for your data structure. It's the same for the channel count. Okay. That demo. Okay. So give me just a small hint when we can go on.
From my point of view, we can go on.
Okay. So a lot of stuff is already in place in that project. So we already have the DB class. We have the root is already in place. We have a books collection. We have books and author. It's the same structure like in the project before. The controller is already in place, but we have some empty responses or some empty methods here. We have to fill it. Another point of that application is that we have that class, that mockup utils class, and I have this because there are some authors and books JSON files in the resource package, and on startup you can see that here in the first method we say mockup utils load mockup data, and then we have to deal with the data. So let's see what happened there. Okay, these are, let's check how many books there are. Okay, around 1,000 books we have, and I think there are some 50 authors. That's okay. Okay, so let's fill those endpoints. The first one is the create books endpoint. So that means we loaded a bunch of books here, which is part of this list, and then we have to put this to our storage. And we have done this several times before, so that should be really straightforward to you. Let's say we have to call the DB class, I guess. Yeah, db.root. It's the entrance, get books, say add all, hand over the objects. That's the first step. And we have done this many times before. Let's say db.storagemanager.store db.root.getBooks. We changed the list of books because we added some, and then we have to store the books. Really straightforward. Okay, let's move on to the next. Create a single one. Author, there is that book. We initialized the book, and we added the author also. Yeah, that is also really straightforward, but we have to take care about, we have to check if that book is already a part of the list. How could we do that? I would say let's try to find a book with the same ISBN, right? So we could do the same like this. So let's get the book collection. Say let's say add book. This is the basic thing we can do. But when we want to check if this book is already in place, we should do a search for that specific book, and we do that based on the ISBN. Let's do that with a stream. So let's say db root get books, and then say, okay, I would say in that case, we can use a parallel stream also. Let's say filter. We do this more detailed for tomorrow, but just for now, filter, and then we say, okay, let's say B for book, and let's say B dot get book or get ISBN dot equals ignore case, because it's a string. So let's use the equals one, and let's ensure that it is the case is ignored. And then we say book dot get ISBN and find first. Let's say find the first one, and this will return an optional. So let's do it like this, and let's say let's assign this to a new local variable, and we get these optional object. So, and that means let's call this optional book. So there might be a book inside or not. We don't know that. We have to check that. And for that, we say if optional book dot is present. So if, and we have to negotiate that. So let's use an exclamation mark here. And then if it's empty, we can add the book. There might be some more elegant ways to check that and to do more stuff, null pointer checks and so on. But just for the training, yeah, as I said. Get ISBN. Yes, that's the optional. Any match. Okay, yeah, could be also, yeah, that's also a great way to do that. Let me just copy that. This will also work. Oh. Could also be a good solution. Yeah. A more shorter one, I would say. Many different ways, but this is pure Java, I would say.
We only need to revert the logic. We add the book if it is not matched.
On this side here, or moment?
Yes, I would say.
Yeah, like this, right? So
yeah,
match. Yeah, yeah, that's right. Returns whether any element of the stream match the provided predicates. Okay, yeah. Match true. Yeah, yeah. You're right. So you can do it like this or like this. That's the same. Okay, so the next one is we already implemented that. It's a get books. It's the easiest one. Let's go further to the next one. Starts with A. That could be interesting. I will wait for your suggestions. If you have a solution, write down it to the comments or to the chat. That gives me time to refill coffee. So let's use this one. So let's say this. Books parent stream. Filter. So book B dot get name dot starts with A. List. So we have another solution that is like this. And there's another one. Might be the same, but I'm not sure. Let's check. I have this one. Let's say return here. And you could say return here. So return. So, okay. So we have the normal stream here. Filter starts with A, collect. Okay, that's the same. Okay, it's totally the same. So yeah, I knew that we don't need this. Okay. Oh, okay, that is not a reachable code. Okay, all the solutions are the same. Last one has a small bug. Parallel stream. Ah, okay. The name should be name instead of ISBN. But
yeah, you're right.
Okay, but yeah, good solution so far. That will work. What about the clear books? The next one, how to delete data within MicroStream. That's also really straightforward. db.root.getbooks.clear. That's it. And of course, we have to store this again. So that means we have to say db storage manager dot store, and then store the db.root.getbooks.
Storage.
One question, if we would call just a second the storage manager, there would be no override. We will create another root, right? So
on this part,
yeah, if we would call only that function, right, db-store getbooks, we wouldn't override the existing route without doing clear. We would create another route.
That store wouldn't happen, because if there are no changes within the books,
right.
when we call this without the clear, the collection will stay the same, and the MicroStream will not fire this store because the collection is unchanged. So that
it's okay. It's not dirty. Okay, perfect. Thank you. Makes sense. Thank you very much.
Christian, don't we miss a parameter on this method on update single book? We need to say what.
Yeah, normally we would do, but just for training purposes, as I said, let's just find a book. Let's just find a single one, a special ISBN or something like that in that example.
Okay, fine.
So let's say, let's have a look to the books itself there. Let's copy one ISBN, maybe the star chamber one here. Let's find that book based on that ISBN, and we can use a stream for that. So let's say db.root.getbooks stream, or parallel stream would be also possible here. Filter, and then a b for book. Let's say b.get ISBN dot equals ignore case, and then we can use this one just to find the book. So let's say find first in that case. Okay. Optional. Let's call this optional book. Yeah, we could use that any match, of course, but just to keep it simple, optional book dot is present. And we can do a change. And this is the case. We don't have that. We had that case in the past. So optional book, let's say get. Now we have the book itself. And now we could do some changes on that book. Let's say book dot set. Let's set the price to big decimal. Okay. I think I have to instantiate a new one. New big decimal. Let's say 50 double. I think that will work. So we load the book, we change the book, and same procedure as every time. We have to store the object which has changed. But this, in that case, it's different because not the collection has been changed. The book itself has been changed. And that's why we say store manager dot store. And now I'm gonna store the book itself. And I would recommend also, we use that DB and all that storage manager stuff directly within the controller class. This is not the way it should be. You should use some data access objects, for example, to have an update method, for example, that makes to separate the different layers of the application. You should not use the DB directly within the controller classes. But it's just for the training, just to understand how it works. So the next one will be interesting. Because this is a special one here. So, and for that we use the same stream. Let's find all books with an A, for example. So we use the same stream for multiple books with an A. Let's say books. Okay, now I have to change those books. So let's do this by, let's iterate through the books. Books dot stream dot yeah, let's say for each, let's say b dot that's not the best way to do.
Yeah, before collecting you can map it maybe.
Sorry,
in the first line when you are collecting the stream, like in place of that you can use map. And
yeah, of course, yeah, I knew that, but I tried to find a simple understandable
okay, yeah, sorry.
Let's do it like this. Maybe for some of us it's more easier to understand, especially for people that don't use streams that often. I think it's much better understandable to do it like this. And let's say b.set price, we can use the same as here. Like this. Let's change this to b. Okay, basically that will work. But now we have to see how can we store that. One possibility would be to call this line of code all the time here. Instead of using books, we say b, and that's okay. This would be one solution, but that is not the best way, because let's imagine we have thousands of books here, for example. Then we have to do the store 1,000 times, and that is not the best possibility to do that. But it's basically, it would work. Another solution could be to say something like that. Let's say db.storagemanager.store, and there is a method which is called store all, and you have to be careful because both methods sound the same, but they do different. When you use this, the second one, the store all with the object instances, then the store all will only store the direct instances which are handover. So, but this one will store the objects within that iterable instance. So that means when we say db.getBooks, the storage manager will store all the objects within that collection with the store all method. And that means that will also a valid way to store the changed one, because as we knew from the example above, we talked about here, when we don't do that, nothing happens. So that means to store all the changed books, it will also work this way. That could also be a solution. Another possibility. But there is another one. And this is, I think that's also a good one. Let's say let's call the storage manager .create a lazy storer. So that creates a lazy store object. Let's call it lazy storer. The name lazy storer is because this lazy storer stores only the object itself without any child objects. That is because it is called a lazy storer. There is another one which is called the eager storer, and eager storing is to store the object with all the child objects in the end. And but in this case, the lazy storer is the default behavior of the storer. And then we can say, okay, lazy storer dot store, and now we can say b. So that means we are able to register the the book object itself on the lazy storer. And when we are done, we can say lazy storer dot commit. So, and in this way, it becomes a little bit like a transaction, I would say. So you can use this for transactions or for something like that. But the transaction part is an MicroStream advanced training part. And we will get more deeper into transaction in the advanced training. But I think that's a great solution also. So this will work, but this is definitely not the best solution. Let's remove that. This one works great, and this one also is a great solution. Both will work, I would say.
I have a question.
Yeah.
When I use the lazy storer, then the application will continue only after the commit will finishes, which means that store it all together.
You mean for the rollback or something like that, or
no? When I call lazy storer.store,
yeah,
somehow buffer the data, and after I call the commit, and it will start storing everything, and it will wait until it's stored to the repository.
Yes. Yes.
Okay, so it's blocking.
It's blocking. Yeah. That's right. All the commits are blocking. Yes.
Okay. Thank you.
Good so far. So I sent you a small script or Word document. You can see that also here on my screen. It's like in school, a small exercise to repeat all the things we have done, all the things we have done or talked about today. Just to repeat that all. Yeah, try to create a project like this. So create a Micronaut project from scratch, add all the necessary dependencies, which are, for sure, only the MicroStream dependencies. Try to create a proper configuration via XML, but I would say it's up to you. You can use the XML configuration, but you can also use the builder configuration. That is up to you. Create a small data model. Let's imagine we have a car company which contains cars and brands, and each car has its own brand, of course. Then we need two controller classes, a car and the brand controller, and in the end we need these 6 endpoints. And especially for the endpoint, just use get endpoints to keep it simple, and do it in the same way like I did to insert one. Just create one by yourself. Don't send one or to hand over one via parameter or something like that. That increases the effort too much. I can show you one example tomorrow where the implementation is done in the right way. So to use the put and all the post methods and so on. But just use get methods. That is totally okay. And during the time, I prepare one example to show you the AWS S3. So we can go through that project in the end. And after that, we have a short look for the topics of tomorrow. And that's it for today. But for now, let's try to do this exercise. I would say, let's say 20 minutes around, or 25 minutes for you to try to realize that example. And then let's have a look to the AWS version. Okay, good luck.
Yeah, I will stay 10 minutes more, but then I will jump 30. So
okay. So I would say let's skip the exercise. As I said, we do the review tomorrow morning. Let's jump straight into the AWS example. I think that's also quite useful. And as I said, we used this also in combination with an AWS Lambdas. This is a quite powerful solution also. But this example I show here is, a normal Micronaut example. And because it needs special configuration to use Micronaut within an AWS Lambda, but that will also work for sure. Okay, let's have a look to the project itself. So we have, as always, a quite straightforward configuration. We have our mockup utils, DB class, data root, all the same like the other projects. But some parts are more extended. So, and this is the part of the DB configuration or instantiation of the storage manager. So basically, what we basically need is a normal initialization of an AWS client. And this is like always, when you want to connect to AWS, you need your access key and your secret access key. You need a credential provider here. And together with all that, you have to create an S3 client. And then you create a blob store file system. And you have to connect with the S3 connector. And that's all you have to do. After that, you use that file system on the instantiation of the embedded storage. You say embedded storage.start and use the bucket name here. So I create a bucket name in that case, and that bucket name is MicroStream storage demo. Let's skip to that bucket. So let me show that to you. Okay, you can see it here. The bucket is empty at the moment. No objects are in it. Let's refresh that. No, it's empty. And we use the mockup utils. We have the controller class here to create those books. Easy. So let's run the application. Here we are. Let's choose this one. And let's say, let's add this, the AWS here. Okay, so let's try to find some books, but for the moment it needs a little bit longer to do all the connection stuff to AWS. But you can see here now the books are empty. When we now have a look to the bucket itself, when we do a refresh, you see the same files like on the hard disk. It's totally the same. But it's empty. Now let's add some books. Let's say books.create. A book successfully created. And when we now call the books again, you see all the books here. It works totally the same like that we store the data on the hard disk. It's quite the same. Of course, the data will change a little bit. It's much bigger data inside. Also on the channel file here, the files are a little bit bigger. But yeah, that's all. To summarize that, you have to create an S3 client with the normal secret access key. After that, create a blob store file system, a blob storage file system, and then hand over that file system here and ensure the path with the bucket name. And I think one important thing is you have to use different dependencies. So let's have a short look to the POM XML. So we use the storage embedded and also the configuration as always. And this is the special one. We use the MicroStream Enterprise feature. I'm not sure about that. It might be changed. This will not be an enterprise feature anymore. So this changed, or that this will change in the next version. But this is already working. But I guess you need another repository. Give me just a second to check that. Yeah, you need to add this repository to your list of repositories in the POM XML, and then you have access to the enterprise features. And yeah, to the AWS S3 connector. Okay, then you can store all your data to an AWS S3. Yeah, it's yeah, also quite easy to use. Any questions to that project? You will okay, let me share the link to that project. So it's this link, but you have to ensure to use the branch S3 implementation done. That is important to use that branch. There is another one, or I guess there is the master branch. It seems that it should work, but yeah, that's not the case. I have to merge some parts of the implementation done to the master in the end. So just choose the implementation done branch. And of course, you have to create your own secrets. These secrets won't work anymore, and then you will be able to connect to your AWS S3. Okay, any questions so far? Then I think let's go shortly through the topics for tomorrow. Let's say, so what to do for tomorrow? We start to improve the exercise. Just have a short look, and let's do this for a small warm-up. I think that's good to start in the day 2. Then we go on with Java 8 Streams API, do some basic introduction to Java 8 Streams, and just create some streams and so on. So I will bring a lot of examples of using the Streams API. Then we have to talk about lazy loading. This will be quite interesting because I try to show you also the memory consumptions of MicroStream in the end, and how to improve your data structure to use lazy loading as good as it could be, I would say. Then we talk about legacy type mapping. That's also important to know what happened when you change some parts of your classes. That's important. And in the end, we talk about some backup strategies. What kind of backups do we support at the moment? And yeah, in the end, let's do some, I would say, some best practice advices from my side, how to use MicroStream, what is the best way, is there a way to see the data? Let's try to connect to that REST endpoint to see the data in the end. Maybe we can have a look to the write data to a MariaDB DB, but yeah, maybe it's a PostgreSQL. Let's see. It depends on the project I have, and that will be the topics for tomorrow.